There is a quiet idea in astronomy that feels almost impossible, yet strangely gentle. The thought of building a shell of light around a star, a structure so vast, so patient, so serene, that it could dim a sun and hold its warmth like cupped hands around a candle. What kind of mind imagined such a thing? And what kind of civilization might grow old enough, wise enough, to attempt it? Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under soft city glow, or drifting in a quiet room somewhere far away, letting the night settle over you? Tell me in the comments. It's peaceful to imagine the AstraFlow community scattered across the world, drifting together beneath the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this small corner of the cosmos keep glowing. Now, settle deeper into your pillow, let your shoulders loosen, let your breath fall into a slower rhythm, and let's begin tonight's voyage into the quiet story of the Dyson Sphere, the dream of a structure wrapped around a star and the civilizations that might one day build such a thing. When we speak of megastructures, the mind often races toward science fiction, toward impossible futures and distant galaxies. But the Dyson Sphere is different. It didn't begin in fantasy. It began as a simple scientific question. If a civilization grew far beyond our own, how would we notice? In the 1960s, physicist Freeman Dyson imagined a species so advanced it no longer relied on the light that happened to reach its world. Instead, it would reach toward the star itself, calmly, deliberately, and gather all of its energy. Not with a solid shell, not with steel walls or a hollow cage, but with countless small collectors, drifting like petals orbiting in the glow. A quiet swarm, a soft cloud of mirrors, a slow, shimmering veil catching every ray a star releases. And perhaps, Dyson suggested, if such structures existed, they would glow gently in the infrared, like red embers in the cosmic dark, a sign we could see, a whisper from a distant civilization carried across light years. Tonight, we will drift through this idea the way one walks through a dream, slowly, softly, letting imagination and science blend like dusk and starlight. We will explore what a Dyson Sphere truly is, why some stars in our sky glow in mysterious ways, how scientists search for these megastructures, and what such a feat would reveal about the beings who might build them. So breathe in and let the world soften. Breathe out and let the night grow quiet around you. The stars have waited a very long time. Let's wander toward them. There is something almost ancient about our relationship with the light. Every life form we know, from drifting plankton to growing forest to our own warm breath, is shaped by the steady rhythm of a star. So when thinkers imagine a civilization capturing the entire energy of its sun, the question beneath the question is quietly profound. What does it mean to hold a star? Not in the way we cup our hands around a flame, and not in the way we harvest the light that spills onto our world, but in a deeper, almost spiritual sense. To gather the full radiance of a sun, to drink every photon it releases, to no longer depend on chance or orbit or distance, only on design, intention, and knowledge. Would such a civilization be reaching for power, or simply trying to survive? Energy is the bloodstream of every world. A planet breathes through its weather, grows through the heat it receives, and rises or falls with the light that touches its surface. And every civilization, even ours, grows more hungry for energy with each generation, to warm homes, to compute thoughts, to explore, to dream, to power the endless flow of life. So the first question is not, how would you build a Dyson Sphere? The first question is softer, deeper. Why would you ever need one? What moment in the arc of a species would whisper, "Now, reach for the star itself"? Perhaps it happens slowly. Population expands. Minds become more intricate. Machines grow clever, quiet, curious. Whole worlds begin to glow with cities, computation, art, and memory. And one day, the light of a single sun, the same sun that once felt infinite, no longer feels quite enough. Or perhaps the need is born from caution, not ambition. A star is generous, but it is also wild. It flares, storms, trembles, and ages. Its warmth is a blessing, and a countdown. A civilization that has seen its own fragility might decide to lift its gaze higher, beyond atmosphere and orbit, toward the raw heart of its cosmic home. The desire to capture a star may not be a gesture of dominance. It might be an act of preservation, a way of saying, "We understand how small we are. We understand how brief the gift of light can be. Let us build something that carries us further." As you breathe gently now, consider the stillness of that thought. Imagine a species not rushing, not conquering, but studying its sun the way one studies a sleeping friend, with care, patience, and a quiet hope for the future. To reach for a star is not to control it. It is to listen to it, to understand its rhythms, and to shape a way of living that can last as long as the light itself. And so our journey begins with this first soft question, settling into the spaces between science and wonder. What would it mean, truly mean, to capture the power of an entire sun? Before we travel deeper, we need to understand what a Dyson Sphere truly is, and what it is not. The popular image is a giant hollow shell wrapped tightly around a star, a perfect sphere capturing every drop of light. But that idea is only a shadow of the real concept. Freeman Dyson's original vision was much softer, much more attainable, and far more poetic. He imagined not a rigid cage, but a drifting cloud of collectors, countless small structures moving in orbit, each one drinking a little sunlight and sending its energy home. Picture a swarm of satellites circling a star the way dust floats in a beam of afternoon light, quiet, unhurried, shimmering as it drifts. That is the true heart of a Dyson sphere, not a sphere at all, but an ecosystem, a stellar garden of mirrored petals, a constellation built by intention instead of gravity. Dyson's insight came from a simple question. If an advanced civilization existed somewhere in the galaxy, how would we ever recognize its presence? He realized that technology at a cosmic scale would leave cosmic fingerprints. A species far older and wiser than ours would eventually reach a point where the energy of an entire planet no longer satisfied its needs. Their hunger would turn upward toward the star that sustained them, toward total access, not partial sunlight. And once they began collecting a significant fraction of their star's energy, we would not see their world, but we might see its consequences. Their star would grow dimmer in visible light, and warmer in infrared. It would glow strangely, like a coal held beneath a veil. Even today, astronomers search for such glimmers, stars that seem to leak heat in unusual ways. Still, the image of a giant sphere remains compelling, almost mythical. It shows up in fiction, in art, in dreams of what distant civilizations might construct. A perfect shell feels clean, elegant, complete. But nature rarely permits perfection at such scales. A rigid sphere would collapse under its own impossible weight. No known material could hold it. Even if you dismantled planets and moons, you would still fall short. A star is simply too vast, so we imagine something lighter. Fragments, clusters, swarms. A structure made not of walls, but of motion. If you breathe slowly now and picture it, you can almost see the architecture of such a design. Thousands, then millions of small collector satellites orbiting in harmony, each one catching the light for a moment before drifting on, part of a vast choreography woven by a patient civilization. Nothing harsh, nothing rushed, just physics, precision, and time. Always time. This is the foundation of the Dyson idea, a gentle reimagining of a solar system. Not conquered, not enclosed, but reshaped into an instrument of survival and creativity. A civilization moving beyond the limits of a single world and choosing to rebuild the relationship between itself and its star. Here, in this quiet thought experiment, we begin our journey, not with steel or fire, but with intention, with the simple, steady belief that a species might learn to grow without outgrowing its light. To understand why a Dyson sphere feels so wondrous, we must first slow down and sit with the nature of a star itself, not as a ball of plasma or a nuclear furnace, but as something more intimate, a steady pulse in the vastness, a quiet engine whose rhythm shapes the destinies of worlds. Every star is a kind of heartbeat. It swells, breathes, and burns in long, patient cycles, pressing light into the darkness the way a chest rises and falls in sleep. Even our sun, so familiar we barely notice it, is a living process unfolding moment by moment, fusing atoms in a core so hot and dense that every photon is born in silence, wandering outward for thousands of years before it ever touches space. When that light finally reaches us, it carries the memory of time we cannot comprehend. If you imagine drifting close to a star, not with your body, but with your mind, you can almost feel the flow. A trembling brightness, ancient and endless, radiating in all directions. It warms entire systems, pulls planets into motion, seeds chemistry, and stirs the early oceans where life might rise. A star is not merely energy, it is possibility. It is the quiet author of everything that breathes, moves, or dreams. For billions of years, a star pours itself outward, never asking, never pausing, its light falling freely on whatever happens to orbit within reach. Planets receive only what chance allows, a slice of illumination, a fraction of warmth. Most of the light escapes into empty space, untouched, unclaimed, drifting forever like a gift without a recipient. This is why the idea of harnessing an entire star feels both impossible and deeply poetic. It challenges us to imagine a relationship far more intentional than the one we have now, a connection not shaped by distance, but by design. When we build solar panels on Earth, we collect only the thinnest whisper of sunlight scattered through atmosphere and cloud. But imagine standing much closer. Imagine structures orbiting directly in the glow, absorbing every ray the moment it leaves the star's surface. Imagine turning a sun into a companion. Not something observed from afar, but something understood, studied, gently reshaped. And yet even as we marvel at the concept, there is humility in remembering what a star truly is. It is not fragile. It cannot be tamed. It does not burn for our sake. Long before any civilization rises or falls, the star continues its ancient work, fusing, radiating, expanding, evolving. If a species ever reaches the point where it contemplates using the full power of its sun, it is not claiming ownership. It is entering a deeper awareness. It is acknowledging the heartbeat that has always been there, steady and unbroken, carrying the history of galaxies within its light. So as you breathe slowly now, imagine that heartbeat echoing softly through space, a rhythmic pulse in the dark, a constant warmth beneath the cosmic cold. And consider how astonishing it is that life, in all its fragility, is shaped by something so immense. A star is both our origin and our anchor. It is the first source of order in a universe that tends towards silence. And it is here, in the quiet glow of this stellar heartbeat, that the dream of the Dyson sphere begins to make sense, not as a conquest of energy, but as a conversation with the very thing that makes existence possible. When we whisper about capturing the full energy of a star, it is easy to underestimate what that truly means. Our minds are shaped for rivers, not galaxies. We understand the warmth of a campfire, the brightness of a lamp, the surge of a storm. But a star radiates power on a scale that dissolves all familiar measures. To hold it in thought, we must slow down, breathe softly, and let imagination expand at its own pace. Every second, the sun emits more energy than all of humanity has used in its entire history. Every heartbeat of the star releases a wave of light so immense it would drown 1,000,000 worlds in warmth. Even the faint sunlight that reaches Earth, after spreading across billions of kilometers, carries enough power to run our entire civilization thousands of times over. And yet that sunlight is only a fraction of what the star produces. Almost all of its radiance flows outward into empty space, untouched, unrealized, disappearing into the vast dark like rain falling into an endless ocean. Think of that for a moment. An ocean of light. A tide that never recedes. A flood that has poured through the galaxy for billions of years, and we, drifting on a small world far from the source, receive only the tiniest ripple at the edge of that sea. Life grows on leftovers, forests, rivers, cities, all powered by a sliver of abundance too great to comprehend. If you try to picture the full output of a star, numbers fail. Even comparisons feel fragile. You could say the sun emits the energy of billions of nuclear bombs per second, but that adds no peace, only shock. A gentler metaphor is needed. Imagine every coastline on Earth illuminated by lanterns. Then imagine those lanterns multiplied across every mountain, forest, desert and sea. Then imagine covering the surface of the entire planet with the lights shining day and night. Now multiply that glow by every world in the solar system, and then multiply again by 10,000. You still have not reached the brightness of the sun. This is the power a Dyson Sphere contemplates, not harnessing a river, not harnessing a planet, but harnessing a cosmic ocean, a continuous surge of luminous energy pouring from a stellar heart. To attempt such a thing requires more than engineering. It requires an understanding of scale so broad it shifts the way a civilization sees itself. It requires patience, humility, and a vision that stretches across centuries. And yet, when viewed through the lens of time, the idea becomes strangely gentle. A Dyson Sphere is not built in a day. It is assembled piece by piece, orbit by orbit, like shells growing around a seed. The star does not resist. The light does not fight back. It simply continues its ancient rhythm, offering its warmth the way it always has. So as you breathe softly now, imagine that ocean of light flowing outward in all directions. Imagine drifting in its glow, feeling its warmth on your skin, knowing that every sunrise you have ever seen is just a whisper from a much deeper brightness. This is the scale of power a star provides. Calm, constant, immeasurable. And it is within this vastness that the dream of a Dyson Sphere begins to feel both humbling and profoundly beautiful. Before imagining how a civilization might wrap itself in the light of its star, it helps to understand the quiet ladder that scientists use to think about cosmic growth. It is called the Kardashev scale, a simple, elegant way of describing how much energy a civilization can use. Not its intelligence, not its morality, not its technology and detail, but its relationship with power, its capacity to gather, direct, and understand the flow of energy that sustains it. In this sense, the scale is less a ranking and more a reflection of how deeply a species participates in the universe around its star. A Type 1 civilization, according to this idea, has learned to use all the energy available on its home planet. Not just sunlight on rooftops, but the heat of oceans, the winds of storms, the pressure of volcanoes, the currents buried beneath the crust. Imagine a world where hurricanes are not feared but harvested, where tides run quiet machines, where no lightning bolt touches the ground without being guided into some gentle purpose. Humanity is not there yet. We still scramble, still spill, still waste, still search. But type Saman represents a kind of planetary maturity, a society that has learned to live with its world instead of simply on it. Then comes type 2. Here the imagination opens. This is the level at which a civilization stretches beyond its skies and looks directly toward the star that birthed it. Instead of feeding only on the energy that falls upon their world, they reach for the full radiance of their sun. Every direction, every angle, every moment becomes an opportunity. They do not wait for daylight. They do not depend on orbit. They learn to gather starlight at the source, calmly, efficiently, with structures that drift and shimmer like petals around a flame. A Dyson Sphere, or more accurately a Dyson swarm, becomes the signature of this level, not arrogance, but understanding, not control, but harmony with the star's endless heartbeat. Beyond that lies type 3, a dream so enormous it feels more like poetry than prediction. A civilization capable of using the energy of an entire galaxy, billions of stars, a web of light stretching across tens of thousands of light years. It is a vision that challenges even the calmest imagination. How could minds evolve to think on such scales? How would time feel to a species that builds with nebulae and trades in the glow of constellations? No one knows, but the scale itself reminds us that growth, at its deepest level, is simply the widening of possibility. As you breathe slowly now, consider how gentle this ladder truly is. It is not about domination or conquest. It is about understanding energy, the language the universe speaks in every sunrise, every aurora, every pulse of a distant supernova. Humanity, right now, is only beginning to whisper in that language. We're a Type 0 civilization, still learning to balance our own fires. Yet the scale invites us to imagine what might come next. Not tomorrow, not next century, but someday, when our relationship with light becomes as steady and calm as the stars themselves. If we listen closely to the rhythm of civilizations, their rise, their learning, their quiet hunger for progress, we begin to understand why a species might eventually turn its gaze toward the full power of its star. The desire for energy is not rooted in greed or conquest. It is woven into the fabric of life itself. Every breath we take is borrowed energy. Every thought is a spark. Every piece of knowledge requires a chain of tiny currents moving through the mind. And as a civilization grows, so too does the gentle tide of its needs. At first, those needs are simple: warmth, food, shelter, safety. Then they expand into communication, memory, exploration, computation, creativity. Cities glow brighter, machines grow more complex, and the invisible infrastructure of daily life grows dense with quiet activity. Even today, our world hums softly with this rising energy, servers storing our memories, networks carrying our voices, satellites guiding our steps. Life becomes interconnected, illuminated, threaded with light. But as a civilization advances, its understanding does as well. It begins to realize that energy is not merely fuel, it is possibility. It is the capacity to build, to think, to imagine futures beyond the narrow boundaries of the present. And with each step toward greater understanding, quantum computing, interplanetary travel, artificial intelligence, the mapping of consciousness, the horizon of what becomes possible stretches farther outward. New dreams require new light. At some point, a civilization that has mastered its planet must face a gentle but profound truth. The world that raised it can no longer sustain its future. Not because the world is insufficient, but because curiosity has grown beyond the surface of a single sphere. The species has matured in its patterns of thought. It has begun to ask questions that extend into centuries, then millennia. Questions about survival, questions about longevity, questions about how to create a future that can endure cosmic time. In that moment of realization, the star becomes something new. No longer a distant presence in the sky, it becomes a potential partner, a wellspring of power that has been quietly overflowing since the birth of the system. 99% of its light is lost to empty space, drifting without purpose into the cold. A Type 2 civilization simply chooses to gather that gift gently, intentionally, to shape a more stable future. There is another layer to this need, one that feels more emotional than technological. Stars age. They swell, dim, tremble, and change. No star remains constant forever. A civilization that survives long enough will eventually contemplate the fragility of its own sun. It will confront the truth that every home star carries within it a timeline, a limit, a quiet ending. Building structures that harvest light may also be a preparation for the far future, a way of learning to live with the star, not just near it, a way of ensuring that life can continue long after the world of origin has changed. So as you breathe softly now, imagine that moment in the history of a distant species, a moment when science, survival, and wonder converge. Not in urgency, but in understanding, a civilization stands beneath its sky, looks toward the star that shaped it, and whispers to itself, "We are ready for more light." When Freeman Dyson first imagined the great stellar structures that now carry his name, he was not dreaming of colossal metal walls wrapped tightly around a star. He was not picturing a perfect sphere shimmering in space like a celestial monument. His idea was far softer, more natural, more in harmony with how the universe already works. Dyson's true brilliance lay not in scale, but in subtlety. He proposed a vision that grew organically from the laws of physics, a vast swarm of independent collectors, each one small, manageable, and drifting freely in orbit. Not a cage, not a prison, but a constellation shaped by intention. To understand the elegance of this vision, imagine standing far above a star, watching thousands of tiny structures circling in its glow. They would look like glitter suspended in sunlight, each fragment catching a moment of radiance before drifting onward. None of them needs to be enormous, none of them needs to be strong enough to span a world. A Dyson swarm is built from patience, not force, from countless smaller pieces, each contributing a fragment of what the species needs. Together, they create a quiet halo of purpose. Dyson was inspired by a simple thought experiment. If an advanced civilization existed somewhere in the galaxy, its technology would inevitably reveal itself through energy. A species that survives long enough will grow in complexity, in knowledge, in imagination. Its cities might glow brighter, its computers might think deeper. Its ambitions might stretch beyond the safety of its home planet. Eventually it would need more light, and if it reached the point of harvesting a significant portion of its star's energy, the star would appear different to distant observers. Dimmer in visible light, warmer in infrared, not vanishing, just transformed. This transformation became the key to Dyson's idea. Look for stars whose glow has changed in ways only technology could explain. It was not about building megastructures ourselves. It was about recognizing the fingerprints of civilizations far older, far more patient, far more advanced. And so he imagined the simplest, most plausible architecture that could create such a signature, not a single impossible sphere, but a dispersed family of orbiting collectors. The beauty of the Dyson swarm concept is that it grows naturally. A civilization does not need to build it all at once. It can begin with a single collector, then another, then hundreds, then thousands. Each device or satellite becomes a seed of energy, a quiet extension of the species' will to survive and evolve. Over centuries or millennia, the swarm thickens. The star becomes encircled not by walls, but by purpose. As you breathe softly now, picture the elegance of this approach. tiny machines drifting like pollen, panels reflecting light like calm water, the star shining on, unbothered, unchanged at its core, yet surrounded by an artificial nebula built with care, intelligence, and time. Dyson did not imagine domination. He imagined harmony, a civilization learning to dance gently around its sun. And this, in its quiet simplicity, is the true beginning of a Dyson Sphere, not an act of cosmic conquest, but a careful choreography written in the language of light. To understand a Dyson swarm, let yourself imagine not a single structure, but a drifting cloud, vast, delicate, and endlessly patient. A cloud made not of vapour or dust, but of mirrors, panels, petals, and quiet machines, each one small compared to a moon, yet purposeful in its orbit, each one turning its face toward the star, drinking light with silent devotion. Together, these countless fragments form a shimmering aura, a soft halo of technology suspended around a sun. If you could float beside such a swarm, the view would be dreamlike. Thousands of reflective shapes gliding through vacuum, their surfaces catching the star's glow and releasing it as gathered energy. Some would spin slowly for stability. Others would sail gently on radiation pressure, adjusting their positions like birds in a thermal. None would collide, none would rush. Every motion would be guided by a choreography older than the structures themselves, the mathematics of orbital mechanics written in arcs and ellipses. The beauty of a Dyson swarm lies in its simplicity. It is a structure grown from many small pieces rather than a single impossible shell. Each collector might be built from local asteroids. Each satellite could be assembled by machines that never tire or forget. Over decades, centuries, and millennia, the swarm thickens. Not abruptly, but organically. One orbit at a time, one new fragment drifting into position. A civilization does not need to leap from scarcity to stellar mastery. It can rise in soft increments, expanding its swarm as its needs. Knowledge and patience deepen. Think of the way coral reefs grow, not in towering monuments, but in quiet layers, each tiny organism adding its small gift to the structure. A Dyson swarm grows the same way, through accretion, not ambition, through time, not haste. It becomes an artificial ecosystem surrounding a star, where every orbiting mirror plays a role in a larger harmony. As the swarm grows, it begins to change the star's appearance. To distant observers, the star might seem a little dimmer in visible light, like a lantern viewed through thin fabric, but in infrared, it would glow with subtle warmth, the signature of waste heat gently released by the collectors. This is the faint fingerprint astronomers look for when searching the sky. Not a beacon, not a message, but a soft red glow where no glow should be. A star warmed by something more deliberate than dust or gas. A star with a companion swarm. If you breathe slowly now, you can imagine drifting among these mirrors. The star ahead is brilliant, but softened by the reflections around you. Each panel glints like a calm ripple on water. Space is silent. The orbits are steady. You feel suspended inside a vast mechanical nebula, a galaxy of human-made constellations arranged not for beauty, but for survival and growth. This is the true essence of the Dyson swarm, not a shell trapping light, but a cloud guiding it. Not a singular monument, but a collective gesture. It is engineering shaped like meditation, countless small points of intention encircling a single source of warmth, a civilization breathing with its star. And in this soft imagery, the idea becomes less like science fiction and more like the natural next chapter of a species that has learned to listen to its own future. If the Dyson swarm is a drifting cloud of mirrors, the Dyson bubble is something more fragile and more elegant, a constellation of light sails suspended by the star itself, not orbiting, not circling, simply floating in a quiet balance, held in place by the gentle pressure of starlight. This idea feels almost like a paradox. Light has no mass, yet it carries momentum. A photon may be tiny, almost weightless, yet it pushes, ever so slightly, ever so softly. And with the right design, that softness becomes a force strong enough to hold structures steady against gravity's pull. Imagine a sheet of material thinner than paper, lighter than a leaf, shimmering like the wing of an iridescent insect. When starlight strikes it, the surface flexes with an invisible touch, a constant, delicate push. If the sail is wide enough, and the balance between radiation pressure and gravity is tuned with precision, the structure can hover in equilibrium, neither falling inward nor drifting away. It becomes a lantern suspended in a river of light. A Dyson bubble would be an entire sphere of these luminous sails, placed at distances where starlight's pressure perfectly counters the star's gravitational pull. The result is a breathtaking sight, a shell not built of steel or stone, but of brightness itself. A shimmering membrane of countless floating surfaces, each one held in position by the quiet breath of the star. No engines needed, no orbits required, just the natural harmony of light and mass. To picture this, imagine drifting outside a star and watching a vast array of sails spread out around it like a luminous blossom. Some are flat like windows, others curve gently like petals. They do not orbit, they do not rush. They hang in starlight, motionless in appearance but alive with subtle adjustments to maintain balance. If a solar flare arrives, they tilt, bow, or fold like leaves in a breeze. If the pressure shifts, they drift slightly until equilibrium finds them again. It is engineering modelled after the behaviour of flowers, seeds, and wings. Responsive, flexible, patient. A Dyson bubble would harvest energy much like a swarm, but with a unique grace. Because the sails do not orbit, they can remain at optimal angles at all times, drinking steady streams of sunlight without interruption. The energy they gather could be sent to distant habitats, stations, planets, or computational arrays, whatever form life has chosen for itself by then. The bubble is less a machine and more an atmosphere, a responsive membrane tuned to the environment of the star. As you breathe gently now, imagine floating near one of these giant sails. The star ahead is brilliant, too bright for any naked eye, but its light is softened by the vast petals around it. Each one reflects a warm glow, each one gleams like a silk curtain drifting in slow motion. Space is silent. The sail vibrates faintly with the star's touch. It feels alive, in the way that all structures shaped by light seem alive. This is the quiet elegance of the Dyson bubble, a sphere not held by force, but by balance, a mega-structure sustained by the star's own breath, suspended in a dance so delicate it feels more like nature than engineering. There is a version of the Dyson Sphere that lives vividly in popular imagination, a colossal, unbroken shell surrounding a star like a cosmic casing, solid and seamless, a mega-structure so immense it becomes its own world. It appears in films, novels, artwork, a perfect sphere catching every ray of light, glowing like a hollow sun. It is beautiful, it is iconic, and in reality, it is almost certainly impossible. To picture why, breathe slowly and imagine the scale. A rigid sphere around a star would need to be millions of kilometers wide, a structure larger than entire planetary systems. It would have to hold its shape against the full force of the star's gravity, which pulls inward with unimaginable strength. Every part of the shell would be under constant tension, like a drum stretched beyond breaking. No known material could withstand such pressure. Steel would buckle, diamond would shatter, even hypothetical materials strain beneath the numbers, but the challenge runs deeper. A shell does not orbit. It floats, suspended in an impossible state, neither falling into the star nor free to drift away. Gravity would pull it inward relentlessly, and there is no natural orbital motion to counter that pull. The structure would collapse long before construction could be finished. Even if one could assemble it, the slightest imbalance, a meteoroid impact, a solar flare, A shift in temperature would warp the entire sphere. A single weakness in one region would cause catastrophic failure across the whole structure. Then there is the issue of mass. If you dismantled every planet, every moon, every asteroid in our solar system, you would still not have enough matter to construct a solid shell of meaningful thickness around the Sun. The viral comparison is stark. Trying to wrap a star with the material of a planet is like trying to wrap a basketball with the material of a human eyelash. The proportions are absurd. The star is simply too vast, too powerful, too heavy. Even the idea of gathering matter from other star systems leads to the same quiet truth. If you can cross interstellar distances to harvest entire planets, you no longer need the energy of a single star at all. Yet the allure of the perfect sphere persists, because it speaks to a deep part of the imagination. The idea of enclosing a star feels symbolic, mythic, as if a civilization could build a new home inside light itself. But the real beauty of Dyson's vision lies not in this fantasy of a rigid shell. It lies in the softer, more plausible alternatives: the swarm, the bubble, the drifting mirrors, the sails balanced on starlight. As you breathe gently now, imagine the difference in sensation. A solid shell feels imposing, forceful, absolute. A swarm feels organic, patient, alive. One strains against the rules of physics. The other grows naturally from them. The impossible sphere dissolves when examined closely, but the dream behind it remains intact. The dream that life might one day learn to shape its relationship with its star, not through brute structure, but through harmony and time. The Dyson Sphere in its truest sense was never meant to be a wall. It was meant to be a conversation, a dialogue between a civilization and the light that sustains it. When we imagine thousands or even millions of collectors orbiting a star, a natural question arises. What would they be made of? Not in a technical sense, but in a cosmic sense. Where would a civilization find enough material to construct an entire swarm, or a bubble of sails, or the vast architecture needed to drink a star's light? To answer this question, we must think in scales far beyond cities or continents. The building blocks of stellar engineering are not mined from mountains. They are carved from worlds. Every planet, moon, and asteroid is a reservoir of elements shaped over billions of years. Iron, carbon, silicates, ices, rare metals, all scattered through the system like seeds waiting for a gardener. A civilization determined to build structures around its star would eventually look outward, not downward, to find the raw matter it needs, dismantling small moons, hollowing asteroids, refining debris left over from planetary formation. These are acts not of violence, but of transformation, turning silent rocks into shimmering collectors that orbit in harmony. Asteroids provide the simplest start. Their low gravity makes them easy to mine, and their compositions contain metals and minerals ideal for building lightweight structures. Automated machines could drift from one to the next, processing material quietly, almost meditatively, turning rubble into panels and frames. Over time, swarms of construction drones might populate the system, converting cold stone into radiant architecture. No rush, no urgency. Just patience unfolding across centuries. Larger worlds offer bolder possibilities. A civilization might choose to reshape a moon, breaking it into manageable fragments, repurposing its mass into thousands of small collectors. Even a single large moon contains enough material to fuel the early stages of a Dyson swarm. But to reach the scale of millions of structures, they would eventually face a deeper question. Would they be willing to disassemble an entire planet? At first, the idea feels extreme. A planet is a home, a cradle, a symbol of origin. But for a civilization spread across habitats, stations, and artificial worlds, place is no longer tied to a single surface. The emotional weight of a planet may fade. What matters is continuity, safety, future. In that frame of mind, Turning a rocky world into a cloud of mirrors becomes an act of cosmic architecture rather than destruction. Even then, the mass of a planet is only a beginning. A rigid Dyson shell remains impossible because no amount of planetary material is enough. But a swarm does not demand such extravagance. It grows gradually, using only what is available, expanding in quiet layers as the species evolves. And because each collector is independent, the system is resilient. One failure does not topple the whole structure. Each new piece is a leaf added to a growing tree of light. As you breathe slowly now, imagine drifting through a system undergoing this transformation. Moons mined into hollow shells, asteroids stripped into shining components, construction ships gliding in silence, carrying fragments of ancient worlds toward new orbits. The star ahead glows with steady warmth, unaware that its children are reshaping the space around it. This is the materials question. Not simply how to build, but how to reimagine entire worlds as the foundations of a future illuminated by starlight. When we imagine a Dyson swarm, millions of collectors, mirrors, sails, and structures drifting through space, it is natural to wonder how such a vast congregation could avoid chaos. How do countless pieces, each following its own orbit, manage to glide without colliding? How does a civilization choreograph a ballet spread across millions of kilometers? The answer lies in a quiet truth. Space is wide, patient, and generous, and motion, when guided by gravity, can become a kind of music. Orbital mechanics is often portrayed as a harsh science. Equations, momentum, velocity, the cold logic of celestial motion. But beneath the mathematics lies a deeper elegance. Every orbit is a rhythm. Every path is a curve shaped by the dance between gravity and motion. When many objects share these rhythms, their motions can interleave naturally, like the weaving of threads in a tapestry. They can pass one another without touching, drifting in gentle harmony. A Dyson swarm would be built on this elegance. Each collector would occupy a specific orbital band, a narrow region of space where its motion remains stable and predictable. Another band would sit higher, moving slower. Another lower, moving faster. The collectors do not need to pack tightly. They have the entire sphere around the star, trillions of cubic kilometers, to spread out. Even millions of objects become sparse at that scale, each separated by enormous distances, each following its own path with quiet precision. Imagine floating in such a region. Around you, in the vastness, collectors drift like stars in formation. One glides ahead, its reflective surface turning gently. Another moves behind, catching a shimmer of light as it passes. Their paths never cross, their motions never conflict. The space between them is so great that collisions become nearly impossible. They are like ships on an endless sea, each with its own course, each held steady by invisible currents. And yet, a civilization would not rely on gravity alone. Small adjustments, made constantly and quietly, would keep the swarm aligned. Solar sails would tilt, thrusters would whisper. Artificial intelligence, or something beyond it, would monitor the slow currents of the swarm and correct every drift before it becomes a danger. Each collector would know its place in the grand choreography, responding to tiny changes in starlight pressure and motion. The whole system becomes a symphony of guidance. Gravity plays the bass. Light provides the melody. The collectors themselves form the harmonies, drifting, realigning, breathing with the shifting balance of the star's environment. It is a choreography without sound, yet full of rhythm, and it grows organically over time. 1,000 collectors become 10,000, 10,000 become 1,000,000. The swarm thickens like a cosmic fog, but never in a way that disrupts the flow. The architecture adapts. The algorithms evolve. The civilization learns the temperament of its star the way a musician learns the temperament of an instrument. As you breathe slowly now, imagine this dance unfolding across centuries. millions of mirrored petals moving in orbit so smooth they feel like meditation. A species learning to choreograph not just machines, but an entire shell of motion around its sun. In the stillness of your mind, the swarm becomes a whisper of harmony, a serene, ordered constellation shaped not by conquest, but by the wisdom of balance. When you imagine a Dyson swarm, picture each collector as a kind of leaf, an engineered leaf drifting through space, turning its surface toward the star the way trees on Earth turn toward the sun. This leaf does not photosynthesize, it does not grow or wilt. Instead, it captures light in its purest form, photons arriving directly from the stellar surface, unfiltered by atmosphere or distance. Every moment, every breath of starlight becomes a stream of energy ready to be transformed into something useful. The science behind this process is simple yet profound. Solar panels on Earth gather only a thin whisper of sunlight. Atmosphere scatters it. Clouds soften it. Night removes it altogether. Even at noon on a clear day, the light that touches your skin has travelled billions of kilometres and lost much of its original intensity. But a collector positioned close to the star feels a very different kind of light. It receives an unbroken torrent of photons, pure, dense, radiant, a river instead of a raindrop. Imagine drifting beside one of these collectors. Its surface is smooth, broad, and dark, designed to absorb as much light as possible. Photons strike it like gentle waves against a shore, each one carrying energy that can be converted into electricity, heat, chemical fuel, or forms of power we have not yet imagined. The collector does not strain, it simply receives, quietly, constantly, without interruption. In this closeness to the star, day never ends. But the magic of a Dyson swarm is not just in the gathering of light, it is in the efficiency. On Earth, even the best solar panels capture only a fraction of the light that reaches them, but a collector positioned in space can operate near the theoretical maximum. No shadow, no weather, no atmospheric scattering. Just the raw heartbeat of the star flowing into its surface. Over millions of collectors, this becomes extraordinary. Each one might gather a modest amount of power, but collectively they absorb a significant fraction of the star's total output. A civilization could channel this energy into anything it needs. Megacities glowing on distant planets, interstellar communication networks, vast computational structures processing centuries of knowledge, or engines pushing ships across the cold between stars. And the collectors need not be rigid or metallic. They could be flexible, like thin fabric shimmering in starlight. They could be made of self-repairing materials, constantly adjusting themselves to maintain optimal alignment. They could reflect unused light toward other panels, sharing illumination in a dance of efficiency. The swarm becomes a living system, a technological forest drifting in the glow of a star. As you breathe gently now, picture the quiet power of this process. Imagine the sunlight that touches Earth magnified thousands of times, gathered at the source, woven into a net of energy that sustains an entire species. There is no sound, no flames, no explosions, just the steady, calm transfer of light into possibility. It is harvesting without taking life. It is gathering without destruction. It is the softest form of power imaginable, daylight transformed into a future. In this stillness, the Dyson swarm becomes more than a structure. It becomes a meditation on abundance, the realization that a star offers more than enough for a civilization that learns to gather its light with patience and grace. Once a civilization gathers the light of its star, the next question arises naturally. How does that energy travel? Capturing power is only the beginning. It must flow outward, like a river, from the collectors that drink daylight to the worlds and habitats that depend on its warmth. And in the quiet vacuum of space, where no wires stretch between machines, energy must travel through light itself. The simplest method is microwave transmission. A collector absorbs starlight, converts it into electricity, and then emits that electricity as a focused microwave beam. Microwaves move cleanly through space, unaffected by darkness, weather, or atmospheric scattering. They travel across millions of kilometers with precision, guided by antennas, mirrors, and feedback systems that correct the beam's direction. When the beam reaches its destination, a receiving station on a planet or an orbital habitat, it is converted back into usable power. Imagine watching one of these beams from a safe distance. You would see almost nothing. No bright line, no crackling arc. Just a faint shimmer in the invisible spectrum, a river of energy flowing between 2 points in the void. The star fuels the collector releases a beam. The receiver catches it like a calm hand cupping water. The process is quiet, continuous, and stable. Another method uses lasers, light sharpened into narrow, intense streams. Lasers carry energy at higher frequencies, allowing for more efficient transmission, though they require more precise aim. A civilization with advanced optics might use thousands of tiny lasers, each one pulsing gently like fireflies communicating across the night. Together they create an intricate web of power lines woven through space, glowing faintly in wavelengths the human eye cannot see. There are even more speculative methods. Particles could be accelerated and sent along magnetic corridors. Energy could move through quantum relays, entangled systems, or technologies beyond our understanding. But even the simplest approach, microwaves travelling between mirrors, creates a network of quiet rivers connecting the star to its children. Picture a world illuminated not by the sun directly, but by energy gathered miles closer to the star and carried home. The night side of a planet could glow softly, its cities powered by beams arriving from the swarm. Distant outposts on moons or artificial habitats far from the warmth of direct sunlight could thrive, bathed in steady, reliable streams of power. Even ships travelling between planets could sip energy from beams that follow them across the void. This system forms an interstellar circulatory network. The star becomes the heart, the collectors become arteries, the receiving stations become organs fed by this constant flow of radiant nourishment. And just as blood carries oxygen to every corner of a body, the beams deliver energy to every corner of a civilization. It is a physiology of light. As you breathe softly now, imagine drifting in the space between two collectors. A beam passes beside you, invisible but powerful, like a warm wind with no sound. You feel the presence of energy moving, not violently, not abruptly, but with the calm persistence of a river flowing through a silent valley. This is the nature of Dyson transmission. A gentle, guided current of light connecting a civilization to its star. In this serenity, the architecture becomes more than technology. It becomes a reminder that power need not be loud or explosive. It can move like a whisper, like a breath, like a soft glow crossing the dark. If a Dyson swarm ever grew dense enough, if its mirrors and sails and collectors multiplied across centuries until they formed a quiet halo around their star, then life within that structure would feel unlike anything we know. To live inside a stellar machine is to exist within a sky that has been reimagined, a sky shaped not only by nature, but by intention. Imagine standing on a habitat orbiting somewhere within this vast architecture. The star would not appear the way our sun does from Earth. It would no longer be a single bright disk in the sky. Instead, its light would be filtered, reflected, softened. You might look upward and see the star through a lattice of distant collectors, each one catching a shard of radiance. The sky might resemble a shimmering mosaic, countless faint glints moving slowly, the light shifting in gentle patterns as the swarm rearranges itself. Day would not be a sudden burst of brightness, nor would night fall as sharply. Everything would move in gradients, soft transitions, muted glows, horizons that fade rather than break. Habitats within a Dyson structure could take many forms: rotating cylinders creating artificial gravity, bubbles anchored to collectors, vast ring-like stations drifting in stable orbits. Life would unfold within engineered worlds, not bound to a single planet. Gardens could thrive beneath mirrored canopies. Oceans could ripple in artificial shallows, warmed by redirected beams. Cities could form on the inside surfaces of megastructural rings, bathed in gentle, recycled sunlight that never truly disappears. And the light itself, this would be the most striking change. On Earth, sunlight is familiar, ordinary, almost taken for granted. It arrives through atmosphere, scattered into blue skies and fiery sunsets. But within a Dyson environment, light becomes a crafted resource. It is shaped, tuned, guided. You might walk through a habitat where illumination shifts like the slow breathing of the star, never too harsh, never too dim, always balanced by the architecture around it. The warmth on your skin would not be direct starlight, but light shared with you through a chain of mirrors and collectors, a gift carried across millions of kilometers. For a civilization that lives in such a place, distance from the star is no longer a limitation. They do not depend on orbit for warmth or photosynthesis. They do not fear long winters or global nights. Light becomes constant, predictable, abundant. It allows life to flourish in ways unfamiliar to us. Forests growing on artificial plains, farms stretching across rotating habitats, cultures forming on worlds that never knew a natural sky. And yet, there would be a quiet wonder to it all. Even while living within an engineered machine, life would remain tethered to the star's ancient pulse, its heat, its rhythm, its steady luminosity. Every habitat, every city, every garden would be aligned to a single source of power, one that continues to burn at the center of this artificial ecosystem. As you breathe gently now, imagine what it feels like to live in such serenity, to walk beneath mirrored constellations, to wake each day in a world shaped by harmony between intelligence and light. A Dyson swarm is not just a machine. It is a home built from the radiance of a star, a place where life grows in the glow of engineered dawns and everlasting warmth. If a civilization ever learned to collect a meaningful fraction of its star's light, it would confront an ancient truth hidden in every flame, every engine, every warm breath on a cold night. Energy never disappears. Even when captured, even when used, even when transformed into motion, thought, computation, or life, it eventually returns as heat. In the quiet physics of the universe, heat is the final language of all activity. And in a Dyson swarm, where a star's radiance is gathered on an unprecedented scale, this heat must go somewhere. Imagine drifting near one of the collectors. It drinks sunlight relentlessly, converting photons into electricity, then sends that energy across space. But some of the energy remains absorbed into the material warming it. The collector must release that heat to avoid overheating. It radiates it outward, not as visible light, but as infrared glow, a gentle warmth spreading into the dark. Multiply this by millions of collectors, and the swarm becomes a cloud of faint thermal embers surrounding the star. Not bright, not obvious, but detectable in the right spectrum. To distant astronomers, this warmth forms a unique signature, a star that appears dimmer in visible light, yet strangely luminous in the infrared. It is the kind of footprint scientists search for, the quiet whisper that something artificial may be shaping the star's environment. And yet, within the swarm itself, this thermal balance is essential for habitability. Too much heat near the collectors could disrupt orbits, weaken structures, or destabilize habitats. Too little, and surfaces would freeze, materials would become brittle, and life would struggle. Thus, a Dyson swarm must breathe, radiating warmth outward in perfect equilibrium, like lungs exhaling after every intake of starlight. This gentle balance governs everything within the structure. Habitats must remain cool enough for ecosystems to thrive, but warm enough to support the comforts of life. Artificial worlds might maintain their own atmospheric cycles, recycling heat in slow currents. Oceans in cylindrical habitats could ripple with faint thermal gradients, heated by energy relayed from collectors before drifting away into engineered night. Even the star enclosed within this halo of structures continues to shine with its own ancient equilibrium. Its surface roils and glows, oblivious to the machines dancing in orbit. The real variable is distance. The closer the swarm is to the star, the hotter each collector becomes. The farther it drifts, the cooler, but the less energy it can gather. A civilization must choose its radius carefully, finding a distance where heat can be shed naturally, where materials remain strong, and where the flow of energy remains steady and safe. As you breathe softly now, imagine the quiet beauty of this thermal dance. A star burning at millions of degrees, collectors absorbing light at blistering temperatures, then radiating warmth like countless invisible lanterns. Habitats drifting in the cooler zones, their climates controlled by delicate balances of reflection, insulation, and artificial atmospheres. Everything in harmony. Everything guided by the simple rule that warmth must always find a path outward. In this stillness, habitability becomes more than engineering. It becomes a form of cosmic mindfulness, a civilization learning to manage the warmth of its own ambition, ensuring that every spark of harvested light returns gently to the darkness without disturbing the serenity of its home. When we imagine a Dyson swarm drifting in perfect harmony around a star, it's easy to forget the immense challenge behind such serenity. The final structure may feel peaceful, almost effortless, mirrors gliding like petals, light flowing like water, but its creation would be one of the most demanding engineering feats in the history of any civilization, not because it requires brute strength, but because it requires patience, precision, and a deep understanding of how to build on cosmic scales without ever disturbing the balance of the star itself. Begin by imagining the first step, launching the earliest collectors. Each one must survive intense heat, solar winds, radiation storms, and the constant pull of gravity. Materials must be lightweight yet resilient. Machines must be autonomous, able to assemble themselves from raw asteroid material. Entire industries must drift into orbit, far from planetary surfaces, building and repairing structures in silence. This civilization must learn to manufacture not just machines, but ecosystems of machines, factories that replicate themselves, construction swarms that grow from a handful of seed units into thousands of coordinated builders. Then there is the challenge of positioning. Every collector must occupy a stable orbit. Too close, and it overheats. Too far, and it gathers too little energy. A swarm that numbers in the millions must be distributed with mathematical grace. A slight imbalance could create cascading collisions or destabilize entire orbital regions. This requires guidance systems more precise than anything humanity has ever built. Sensors that feel the faintest change in pressure, algorithms that respond to solar winds like leaves reacting to a breeze, networks that communicate at the speed of light to prevent even the smallest drift from becoming dangerous. Construction is slow by necessity. A Dyson swarm cannot be rushed. Growing too quickly risks instability. Growing too slowly risks obsolescence before completion. A balance must be found, not unlike the balance of temperature, orbit, and harmony within the structure itself. The project becomes intergenerational, a story passed from parent to child, carried forward through centuries of continuity. Tools evolve, methods shift, materials improve, knowledge deepens, but the dream remains the same. A civilization building a vessel made of light. And then there are the environmental challenges. solar flares bursting from the star's surface, coronal mass ejections hurling charged particles across millions of kilometres, variations in stellar output that force constant adjustments in the swarm. Each event must be monitored and anticipated. Collectors must be able to fold, tilt, or retreat from dangerous regions. Sails must adjust their orientation. Algorithms must reroute beams, redistribute power, reposition habitats. Engineering becomes not a static achievement, but a dynamic relationship with a living star. As you breathe softly now, imagine these challenges not as obstacles, but as forms of cosmic problem-solving, a civilization learning to work with the universe instead of against it. Each machine launched into orbit is a promise. Each adjustment in the swarm is a breath. Each generation contributes a layer of craftsmanship, a refinement of understanding. Over time, the megastructure becomes a testament to patience, a quiet monument shaped not by force, but by collaboration between intelligence, physics, and light. In this meditative frame, the engineering of a Dyson swarm feels less like construction and more like cultivation, an act of nurturing a luminous garden around a star grown with care, resilience, and the long memory of a civilization seeking continuity in the glow of its ancient sun. To understand the true scale of building a Dyson swarm, imagine the weight of a moon held in your hands. Then imagine dismantling that moon piece by piece, refining every grain of dust and turning it into a drifting constellation of mirrors around a star, and then imagine doing it again and again. Not with violence or haste, but with deliberate calm across centuries, until enough material exists to form a luminous halo that drinks the full power of a sun. This is the magnitude of the task, a project so vast that no single world, no single generation, no single blueprint is enough. The raw matter required, metals, silicates, carbon structures, ultra-light composites, must come from many places: asteroids, dwarf planets, icy moons, the remnants of ancient collisions. Every small world becomes a reservoir of possibility. Every mined crater becomes a quiet contribution to the architecture of the future. At first, this seems unthinkable. Humanity, after all, is still learning to build cities, not stellar webs. But imagine a civilization that has grown far beyond our present moment. A species that has automated construction, mastered resource extraction, and spread its presence across the quiet corners of its solar system. For them, dismantling a small moon might be like clearing a valley. Mining an asteroid becomes like gathering fallen branches. The scale is enormous to us, but to them it is simply the terrain of their engineering. Picture thousands of machines drifting in silence above a rocky world, autonomous harvesters slicing the surface into manageable fragments. Other machinists crush the material, refine it, and assemble it into wide, thin collectors. Conveyor swarms carry completed panels to orbital launchers that fling them gently into predetermined paths. Each panel joins the steady flow of structures gathering around the star, another petal in an expanding bloom of engineered light. No one stands beside these machines. No single hand guides them. The civilization's role is not to manually build the swarm, but to guide an ecosystem of robots, algorithms, and self-correcting networks. Construction becomes a rhythm, slow, stable, persistent. The swarm grows not like a skyscraper rising in a city, but like a forest spreading across centuries, each new layer built upon the memory of the last. And still, despite this automation, the emotional weight of the work remains profound. The dismantling of worlds is not done lightly. Each moon or planet carries history, formation, orbit, geology, maybe even myths from earlier eras. To repurpose such worlds requires a shift in perspective, a belief that the future of the civilization and the continuity of its light outweigh the sentiment of leaving celestial bodies untouched. It is a trade, not of destruction, but of transformation, exchanging raw mass for a new kind of sky. As you breathe gently now, imagine standing on a platform above a fragmented moon, watching the horizon sparkle with machines. Imagine knowing that every stone lifted from its surface becomes part of something far greater, part of a lattice of collectors that will cradle the star for millennia. The effort spans ages, but the vision remains steady, a civilization shaping its own cosmic environment, one fragment at a time. In this serenity, the construction scale becomes less overwhelming. It becomes a meditation on continuity, an understanding that to build on the scale of stars is to think in slow, patient breaths, trusting that every small act contributes to a luminous whole. A star may look serene from the distance of a planet, a steady circle of brightness rising and setting with comforting predictability. But up close, a star is anything but calm. It trembles, it erupts, it breathes fire in rhythms older than planets themselves. Its surface roils like a boiling ocean of plasma, and deep within, magnetic fields twist and snap, releasing storms of energy with a force beyond imagination. For any civilization daring to build a Dyson swarm, these storms become one of the universe's most formidable challenges. Solar flares burst from the surface with little warning. They eject streams of charged particles that race outward at millions of kilometers per hour. Coronal mass ejections, the great expulsions of stellar plasma, can fill a region of space larger than entire worlds. Even the quiet glow between eruptions hides a restless furnace, constantly shifting and reshaping its magnetic labyrinth. A collector placed near such a star must be built to endure the heat, withstand the radiation, and adapt instantly to sudden changes in the flow of stellar wind. Imagine drifting close to a collector when a flare erupts. The panel, thin and delicate as it may seem, must react faster than any human reflex. It tilts, folds, or shifts its orientation to avoid catastrophic damage. Some surfaces turn reflective to deflect excess energy. Others retract into protective configurations like flowers closing against a harsh gust. The swarm as a whole might shift its formation slightly, redistributing collectors to safer regions while algorithms reroute energy pathways. Everything happens quietly, but the complexity is staggering. Millions of machines adjusting in synchronized precision, guided by an intelligence, artificial or biological, capable of reading a star's moods. The star itself is not hostile. It does not intend harm. Its storms are a natural part of its life cycle, much like the changing seasons of a world. But for a civilization living in close partnership with its star, relying on its energy, building structures within its glow, understanding these storms becomes essential. They must learn to read the signs of an impending flare, to anticipate the rise and fall of magnetic tension, to predict the timing of its eruptions with a mastery that surpasses anything humanity has yet achieved. Over time, the civilization grows not just technologically, but intuitively. Their models become more refined, their collectors become more resilient. They develop materials that bend without breaking, electronics that endure radiation levels unimaginable to us, and control systems that can adjust an entire swarm with the fluidity of a single breath. They begin to see the star the way a sailor sees the ocean, not as a threat, but as a living, shifting environment to navigate with care. As you breathe slowly now, imagine the serenity of such mastery. A star erupts, but the swarm responds in harmony, like a flock of birds adjusting to a sudden gust of wind. The collectors shimmer, shift, and realign until the danger passes. Then everything returns to its quiet rhythm, the star's light flowing once more across the vast lattice of mirrors and sails. In this relationship there is no struggle. There is only adaptation, an ongoing conversation between intelligence and the luminous heart of a star, a dance of resilience woven into the very structure of the megasystem. If a Dyson swarm ever surrounded a distant star, its presence would not announce itself with bright signals or obvious shapes. There would be no gleaming silhouette, no artificial shadows stretching across the galaxy. Instead, its signature would be subtle, quiet enough to hide within the ordinary glow of the cosmos, and yet, for those who know where to look, that subtlety becomes a clue, a cosmic whisper. Look in the warmth, not the light. This is the essence of the infrared search for megastructures. A Dyson swarm, as elegant as it may be, blocks some of the star's visible light, but the energy it absorbs does not vanish. It re-emerges as heat. Millions of collectors radiating their excess warmth create a faint red aura around the star, like embers glowing softly beneath ashes. To our eyes, the star might look normal, but to an infrared telescope it shines in a way that does not match its temperature, its age, or its expected brightness. Astronomers build catalogues of stars, millions, even billions of them, recording their colours, their spectra, their patterns of light. They compare these readings to models of what a star should look like if left untouched by technology. Most stars behave exactly as expected. Their infrared signatures match their natural life cycles. But a few, scattered through the darkness like misplaced notes in a song, glow redder than they should. Too warm, too bright in infrared, too dim in visible light. These are the anomalies, the candidates, the quiet mysteries of our galaxy. Scientists sift through these anomalies with care. Dust clouds can mimic the glow of a Dyson swarm. Young stars wrapped in forming planets can shine strangely in infrared. Even distant galaxies, hidden behind a star by coincidence, can create deceptive signatures, and so every candidate must be tested, filtered, analysed with patience. Most are eventually explained by natural processes, yet the search continues, not because we expect to find something tomorrow, but because the possibility itself, however faint, opens a door to wonder. Imagine sitting at a telescope console late at night, surrounded by screens showing spectra and scatter plots. Amid billions of ordinary stars, you notice one whose infrared glow doesn't match its expected pattern. It is not bright, it is not dramatic, it is simply wrong in a gentle, intriguing way. You run more data, you compare its temperature, its age, its composition. Still, something lingers. Perhaps this is dust, perhaps this is youth, perhaps this is coincidence, but perhaps, just perhaps, it is a star surrounded by structures that sip light and release warmth. This method of detection is one of the few ways we could ever discover an advanced civilization without hearing from it directly. No messages, no signals, no intentional communication, just physics, energy in, energy out. A Dyson swarm would not need to announce its presence. It would reveal itself simply by existing. And in that simplicity lies a quiet beauty, as if the universe has left traces of intelligence hidden in its own glow. As you breathe softly now, picture scientists scanning the sky, searching for patterns in the warmth of distant stars. They are not chasing fantasies. They are listening to the infrared murmurs of the cosmos, hoping to catch a whisper from a civilization that might have wrapped its life around the light of its sun. This is the infrared roadmap, a search not for noise, but for silence disrupted ever so slightly by the warmth of something artificial, something patient, something enduring. Among the countless stars catalogued by astronomers, a few, just a tiny handful, shine with a kind of quiet strangeness. They do not flicker or flare in dramatic ways. They do not pulse like dying giants or whirl like fast-spinning dwarfs. Instead, their anomaly is subtle. They glow more brightly in the infrared than a star of their age and temperature should. Their warmth is too soft, too constant, too persistent. Their light does not match the story astrophysics expects them to tell. In recent surveys, researchers identified 7 such stars, 7 warm glimmers in the vast datasets gathered by telescopes scanning the sky. Not 7 messages, not 7 signals, just 7 quiet inconsistencies. Stars that whisper instead of shout. Stars that refuse to align perfectly with the predictions of stellar models. Stars that radiate a little more heat than they should, as though something around them were collecting light and releasing a portion of it back into the dark. When news of these candidates surfaced, it rippled through both scientific circles and the public imagination. A Dyson swarm absorbs visible light and re-emits heat, creating precisely this kind of thermal signature. 7 stars glowing too warmly. 7 stars dimmer in visible spectra, yet too bright in infrared. It was enough to make people wonder, carefully, responsibly, but wondrously, whether these anomalies might be more than dust, more than youth, more than coincidence. And so the questions began. Are these stars wrapped in natural dust clouds? Are they young suns surrounded by debris from forming planets? Are they aligned with distant galaxies that just happen to glow behind them? Or, allowing ourselves the softest whisper of possibility, could they be surrounded by megastructures that catch starlight the way forests catch morning dew? Scientists approach these mysteries with humility. Each candidate must be examined with caution. Data must be cross-checked, catalogued, compared, filtered. False positives outnumber genuine anomalies by wide margins. Dust mimics technology. Planet-forming disks create thermal illusions. Colliding worlds generate temporary heat. The universe is full of natural processes that can masquerade as intelligent design. But even with all these explanations, the 7 stars remain intriguing. Their warmth cannot yet be attributed to any single natural cause. They sit in a quiet category, plausible, unexplained, deserving of deeper study. Not evidence of civilization, not proof of megastructures, but not dismissed either. Instead, they linger in the space between knowledge and imagination, a perfect place for curiosity to breathe. Imagine looking at one of these stars from a telescope's infrared display. It does not shimmer or pulse. It simply glows a few degrees warmer than expected, its light gently shifted into red wavelengths. Nothing about it declares intention or intelligence, yet something about it feels deliberate, as though the warmth carries a rhythm not entirely random. The mystery is soft, subtle, and strangely calming. It reminds us that the cosmos still keeps secrets. As you breathe gently now, consider the quiet power of these 7 candidates. They represent not just possibilities, but humility, the understanding that our models are incomplete, our knowledge partial, our interpretations provisional. These stars invite us to keep asking, keep searching, keep wondering, not with urgency, but with patience, openness, and awe. In this stillness, these 7 warm glows become more than anomalies. They become lanterns of curiosity, signs that even in an age of vast data, the universe can still surprise us with mysteries wrapped in gentle warmth. Whenever astronomers encounter a star whose warmth doesn't quite make sense, the first question is never, is this a megastructure? The first question is always gentler, more grounded. What natural story could this star be telling? Because the universe is filled with phenomena that can mimic the thermal signature of a Dyson swarm, phenomena born not from intelligence, but from physics, gravity, youth, and time. One of the simplest explanations is dust. Dust plays tricks with starlight. It absorbs visible photons, warms them, and re-emits their energy as a soft infrared glow. If a star drifts through a dusty region of space, or if dust lingers from ancient collisions, its infrared brightness increases even though nothing artificial surrounds it. The warmth spreads like a faint ember, making the star appear older, redder, or more obscured than it truly is. Dust can blanket a star in a shimmering veil, turning its light into something that resembles the glow of collectors, even when no collectors exist at all. Another natural possibility is stellar youth. Young stars often wear thick disks of gas and debris, remnants of the planet still forming around them. These disks can radiate enormous amounts of heat as they swirl, collide, and compress. From afar, such a star can look suspiciously like one surrounded by energy-collecting structures, but in truth, it is simply growing, birthing planets, shaping moons, stirring the ingredients of entire future worlds. Youth carries its own signature of warmth. Then there are planetary collisions, the dramatic but natural events that occur when two large bodies crash into each other. Such an impact can release vast amounts of energy, sending dust and molten fragments spiraling outward. The aftermath glows brightly in infrared, sometimes for decades or centuries. To a distant observer, this temporary heat resembles the footprint of a Dyson swarm. Yet beneath it is only chaos, the byproduct of worlds reshaping themselves through gravity's relentless dance. In some cases, what appears as a single anomalous star isn't a star at all. It may be a distant galaxy aligned perfectly behind a foreground star, its collective infrared glow leaking through just enough to distort measurements. These coincidences are rare, but they happen. The sky is deep. Lines of sight stretch across millions of light years. The universe often overlaps with itself in ways that confuse even the most careful instruments. These explanations matter because they remind us of humility. The cosmos is not obligated to simplify its signals for our understanding. Not every anomaly is artificial. Not every strange glow is a megastructure. In fact, most are not. And yet, we search. Not because we expect every mystery to point toward intelligence, but because the act of listening makes us better observers of the universe's natural rhythms. As you breathe softly now, imagine each of these natural processes unfolding in silence. A dust cloud drifting like cosmic fog, a young star wrapped in a warm, swirling cradle, two planets colliding and reshaping themselves into something new. A distant galaxy shimmering behind a nearer sun. These are not failures of our search. They are stories. Stories of heat, birth, destruction, and time. And they teach us something profound, that the universe is full of ways to glow. A Dyson swarm is only one of them. The others are written in dust, motion, impact, and youth. And before we reach for the extraordinary, we must understand the ordinary. Because even the ordinary, when viewed through the quiet lens of the night, is full of wonder. There is a softly surprising idea whispered by some astrophysicists, an idea that reframes the entire concept of a Dyson sphere in a way both humbling and beautiful. A star already carries its own kind of Dyson shell. Not an engineered megastructure, not a lattice of mirrors or a cloud of artificial sails, but a natural layer of gas and plasma that performs in its own cosmic way the same essential role. It absorbs energy deep within, transforms it, and radiates it outward with perfect grace. To understand this, imagine peeling back the layers of a star. At its core, nuclear fusion ignites, forging light under unimaginable pressures. This energy does not race outward instantly. It travels through layers, dense, hot, opaque, taking hundreds of thousands of years to escape. As it moves outward, the star's envelope absorbs and reprocesses this light, changing its character, its temperature, its colour. What finally emerges at the surface is not the raw, violent pulse of fusion, but a softened version, gentled, filtered, diffused. In this sense, the star's outer envelope behaves almost like the shell of a Dyson sphere. It catches the energy within and re-emits it in a form the universe can receive. It wraps the core in a layer of regulation and transformation. It manages the raw output of the star with a kind of natural engineering so elegant that no civilization could hope to match it. The star moderates itself. It contains itself. It radiates safely, because a shell of its own substance stands between its core and the infinite dark. This perspective softens the boundary between natural and artificial. It suggests that the dream of enclosing a star is not as alien as it seems. We are not imagining something unnatural. We are imagining something inspired by the star's own architecture. A Dyson swarm simply mimics, in a delicate and technological way, what the star has always done: capture light, transform it, release it. There is a quiet humility in this realization. No matter how advanced a civilization becomes, no matter how many collectors it launches into orbit, no matter how gracefully it rearranges the flow of energy around its sun, it will still be learning from the star itself. The patterns of stability, the rhythms of heat, the balance of pressure, the art of radiating more gently than one absorbs. Nature remains the first engineer of megastructures. As you breathe slowly now, envision drifting just above the star's surface, not close enough to be overwhelmed, but close enough to feel the movement beneath. The envelope churns like a living ocean. Light rises through it in waves that take millennia to complete their journey. The surface glows with the softened breath of energy that has travelled through layers of self-containment. Without knowing it, every star practices the very principle civilizations dream of mastering: how to manage the flow of radiant power. And so, the boundary blurs. A Dyson swarm becomes not a challenge to nature, but a continuation of its logic. A civilization builds mirrors around its sun because the sun has already shown how to hold light gently, how to regulate brilliance, how to transform raw creation into a gift shared with the cosmos. In this stillness, the idea feels less like engineering and more like imitation. The quiet recognition that stars themselves are the original megastructures, and every artificial design is merely a reflection of their timeless wisdom. When we speak of Dyson spheres, it is tempting to imagine them as distant miracles, wonders crafted by civilizations far older, wiser, and more enduring than our own. But eventually the question drifts back to us, quietly and naturally. Could humanity ever build something like this? Could our species, fragile and early in its story, ever reach a point where shaping the light of the sun becomes more than a dream? To answer this, we must first accept where we stand. Humanity is still a Type 0 civilization on the Kardashev scale. We do not control the weather. We do not harness the energy of the oceans or the core of our planet. Our mastery of sunlight is partial, local, scattered across rooftops and deserts. Even our closest ventures into space have been light and fleeting. A few footprints, a handful of probes, brief visits to orbiting stations. The idea of shaping an entire solar system may feel impossibly far away, and yet the seeds of such a future already exist. Every solar panel glinting in the sun is a whisper of what might come. Every asteroid studied by a probe is a reminder that resources lie beyond Earth. Every autonomous robot, every quantum computer, every self-correcting algorithm is a tiny precursor to the networks a Dyson swarm would require. Our tools are primitive compared to what would be needed, but they are real, and they grow. A Dyson swarm does not demand miracles. It does not require a leap of impossible technology. It requires accumulation of knowledge, of patience, of generations willing to build slowly. It requires a shift in perspective, away from fossil fuels and finite reservoirs, toward the reality that our star offers more energy each second than we could ever exhaust. It requires us to master orbital construction, automation, precision manufacturing, and long-term planning. None of these are beyond reach. Each is a mountain, yes, but mountains are climbed not by leaps, but by steps. Imagine humanity beginning with the smallest foundation, mining a single asteroid, converting its material into a handful of collectors, launching them into orbit not around Earth, but around the Sun. They gather a trickle of power, enough to support research or empower distant satellites. Then the swarm grows. Hundreds, then thousands of panels. Factories in orbit replicate themselves, learning to harvest materials from asteroids without ever returning to Earth. Human presence becomes optional. Machines operate tirelessly, building the scaffolding of a future our great-grandchildren may inherit. Culture would need to change as well. A project spanning centuries demands unity, continuity, and foresight beyond any single lifetime. But consider how many human structures already rely on generational stewardship. Cathedrals, libraries, scientific traditions, languages, ideas. Humanity is capable of thinking across time when we choose to. As you breathe softly now, imagine the far future. Not tomorrow, not next century, but an age where humans, or the beings we become, live among habitats scattered through the solar system. Where the sun is not merely a source of warmth, but a partner in survival. Where fragments of artificial light shimmer in orbit, not as symbols of dominance, but as expressions of hope. Could humanity ever build a Dyson swarm? Not today, not soon. But the question is not whether we are capable at this moment. It is whether we are willing to grow patiently toward a future illuminated by the light we learn to gather wisely. If the dream of the Dyson swarm feels distant, almost mythic, then the pathway toward it begins with something far more humble: an asteroid. A small, silent world drifting in the dark, rich with metals and minerals that once formed from the dust of ancient stars. Before humanity could ever reshape a solar system, it must learn how to work with these wandering stones, to mine them, to refine them, to build from them without relying on the fragile surface of Earth. Asteroids are the perfect beginning, not because they are easy, but because they require us to grow in precisely the ways a Dyson project demands. They float in microgravity, demanding new engineering methods. Their materials must be extracted without atmosphere, without oceans, without the comfortable tools we evolved with. They require robotics, automation, and machinery that can operate for years with minimal human presence. They ask us to think in the language of space, not the habits of Earth. Imagine a mining probe approaching a dark, rotating asteroid. It anchors itself with delicate arms or harpoons. Sensors map its structure, revealing pockets of metal, ice, carbon compounds. A swarm of micro-robots emerges, scattering across the surface like metallic insects. Some drill, some melt, some transport. Others build small factories that use solar power to refine the raw material into ingots or thin sheets. Each robot contributes a tiny step in a process that may continue for decades. This is not a rush. Space does not hurry. Machines drift patiently, collecting regolith, compressing it, melting it into usable forms. When enough material is prepared, a launch system, perhaps an electromagnetic rail, perhaps a solar sail, sends the refined components gently toward a staging orbit around the Sun. There they wait. Collectors, panels, and structures are assembled modularly, piece by piece, like leaves on a quiet tree growing in zero gravity. At first, humanity might build only a few such collectors. They would not power cities. They would not change the brightness of the sun, but they would test the methods: autonomous manufacturing, long-duration operations, energy capture. The early swarm would be tiny, hundreds of meters wide perhaps, yet each collector would teach us more about how to build at scale. Then comes the next step: establishing permanent facilities. Mining stations on asteroids would grow into hubs for production. Orbital yards would assemble satellite components in sunlight without the cost of launching heavy materials from Earth. Meanwhile, humanity spreads further, perhaps to Mars, perhaps to the moons of Jupiter, perhaps to giant rotating habitats that become homes for generations of builders. Each new settlement would require power, industry, communication. Each would be integrated into the growing solar infrastructure. In this way, the first steps toward a Dyson swarm are quiet. They are methodical. They are slow, deliberate breaths taken by a civilization learning to work among the stars. There is no single moment when the project begins. Instead, it unfolds naturally as the species matures, mining one asteroid, then another, then thousands. Gradually, a solar economy emerges, not as an ambition of conquest, but as a rhythm of growth. As you breathe gently now, imagine drifting near one of these mining sites. The asteroid turns slowly beneath you, its surface glittering with the reflections of robotic lights. Above it, in the vastness, floats the first shimmering petal of a future Dyson swarm, a symbol not of technology alone, but of humanity learning to extend its hands toward the sun with patience, intention, and care. Long before a Dyson swarm fills the sky with mirrored petals and drifting sails, a civilization must begin with something far smaller. Prototypes, the first fragile seeds of a colossal future. These early collectors would not reshape a star's light. They would not dim its glow or warm the infrared spectrum. They would barely be noticeable, even up close. And yet, in their simplicity, they would carry the full weight of a civilization's intention. Imagine the very first collector ever launched toward the sun. It is not elegant, not yet. Perhaps it is no larger than a billboard. A thin sheet of reflective material stretched over a lightweight frame. It unfolds quietly in space like a metallic flower encountering its first dawn. Instruments hum softly on its surface. Tiny thrusters breathe out faint puffs of gas. Solar wind nudges it like a gentle hand. It is a humble machine, but it is the beginning of a new relationship between life and its star. These early prototypes teach essential lessons. How does the material withstand the relentless heat of unfiltered starlight? How do delicate sensors endure radiation storms? How must the collector tilt, pivot, or fold to maintain stability? How does it communicate with other machines, or with home bases scattered across the solar system? Every experiment reveals something. Every success expands confidence. Every failure becomes a footnote in a growing book of wisdom. Slowly, the fleet of prototypes expands. A dozen collectors become 100. Engineers test different geometries, broad wings for maximum absorption, curved mirrors for focusing light, thin sails that drift on radiation pressure, compact arrays that fold and unfold like origami. Some designs are simple, flat panels catching sunlight like quiet windows. Others explore new techniques, materials that almost heal themselves when struck by micrometeorites, coatings that change their reflectivity depending on temperature, frames that flex rather than break under pressure. Orbit by orbit, these collectors begin to form small clusters. A few drift together in coordinated formations, experimenting with shared power distribution and mutual stability. Beams of energy flicker between them, like faint threads weaving the beginnings of a web. The prototypes learn to align themselves with exquisite precision, adjusting constantly to the subtle forces of gravity, solar wind, and orbital drift. They are tiny dancers in a vast silent ballet. And as more prototypes join the sky, something remarkable begins to happen. The civilization starts to see its star differently. Not as a distant sphere of fire, but as an anchor of opportunity, a partner in a long-term project, a source not just of light, but of continuity. The prototypes become a new kind of constellation, not mapped by myth, but built with purpose. When viewed from afar, they glint like soft sparks against the darkness, small but unmistakably artificial. These first seeds do more than test technology. They inspire confidence. They demonstrate that even the smallest fragments, placed carefully in the right orbit, can contribute to a structure of unimaginable scale. A Dyson swarm is not built in a single leap. It has grown through countless tiny decisions, Countless incremental steps, countless polished fragments drifting toward a shared horizon. As you breathe gently now, imagine floating near one of these prototypes. It hums softly, warmed by the sun's unfiltered glow. Around it, other prototypes drift in quiet formation. Their reflections shimmer across your visor, each glint a small promise of the future. You realize that even the grandest cosmic dreams begin with something simple. A single leaf of metal unfolded into starlight. When a civilization learns to gather the full radiance of its star, a new horizon opens, one not defined by scarcity but by possibility. Energy becomes more than a resource. It becomes a language of creation. With enough power, worlds that once seemed barren can be warmed. Atmospheres can be shaped. Frozen moons can be awakened. Entire planets, long silent and cold, can be guided gently toward life. This is the promise hidden within a Dyson swarm, not the domination of space, but the quiet potential to restore, reshape, and revive. Imagine standing on the surface of a distant moon. Its sky is thin, its air almost absent, its horizon sharp and cold beneath a distant sun. Life feels impossible here. But now picture a stream of energy, steady, controlled, arriving from collectors orbiting close to the star. It may come as heat, directed toward engineered receivers embedded in the moon's crust, or as power-feeding machines that release greenhouse gases in a careful measured dance. Over decades, the surface warms, ice melts, a faint atmosphere begins to gather, the world exhales for the first time in millions of years. Terraforming is not magic, it is patience. It is the slow rewriting of conditions 1 degree at a time. Without the energy of a Dyson swarm, such a project would be overwhelming, perhaps impossible. But with the near-limitless power of a star flowing through a network of collectors, the process becomes feasible. Moons with subsurface oceans could be heated gradually until pockets of water reach the surface. Rocky planets with thin atmospheres could receive enough energy to spark weather cycles. Even the most distant bodies, icy giants at the edge of the system, could be warmed into new forms of habitability. And beyond terraforming lies another vision: artificial worlds built not from planets, but from pure engineering. Cylinder habitats rotating to create their own gravity. Hollowed asteroids transformed into biodomes. Vast spheres of living space powered entirely by beams of starlight. These constructs would not rely on fragile planetary environments. They would be designed, curated, shaped with intention. Their ecosystems could be tuned carefully like gardens, sustained by the constant power flowing from the Dyson network. A civilization with Dyson-level energy could even extend life beyond its original system. Ships could travel between stars using propulsion unimaginable to us: fusion drives, antimatter engines, or technologies that bend space-time. And every such journey would be powered by the same source, the quiet, constant glow of the star captured by millions of collectors. Yet despite this breathtaking scale, the heart of the idea remains gentle. Terraforming is not an act of conquest. It is an act of care. A gesture toward places that have waited in silence for eons. The energy from a Dyson swarm is not a weapon. It is a sunbeam redirected with love. As you breathe softly now, imagine drifting in orbit above a world undergoing transformation. Below you, patches of green begin to appear where there was once only rock. Thin clouds form. Rivers carve their first paths. The world is waking up, warmed by the patient hands of a civilization that learned to gather its star's light. In this stillness, the possibility becomes clear. The energy of a Dyson swarm is not merely power. It is potential. It is the ability to carry life where none existed before, to seed warmth into the cold, to let new worlds bloom beneath unfamiliar skies. Every thought you have ever had, every memory, every emotion, every quiet moment of awareness, has required energy. A spark through a neuron, a chemical shift, a pulse of electricity carrying meaning along delicate wires of living tissue. Consciousness, at its core, is powered by the faintest flow of charge. And when a civilization evolves far beyond its beginnings, its collective consciousness grows as well. Minds become more numerous, more connected, more curious. They build libraries of thought, oceans of data, vast networks of memory that must be stored, processed, and shared. For such a civilization, energy becomes more than a physical resource. It becomes the price of thought itself. Imagine a species with billions, perhaps trillions of individuals, whether biological, synthetic, or something between. Each being thinks, learns, dreams. Each maintains a personal history that must be recorded or remembered. Their cities shimmer not with light, but with information moving through invisible veins. Their computational clouds process countless decisions each moment. Their science grows deeper, their art richer, their imagination more expansive. And with each new layer of complexity, the energy required to sustain their collective consciousness increases. Even today, humanity stands at the faintest edge of this truth. Data centers already glow with the heat of our curiosity. Every search, every message, every stored photograph demands electricity. Our emerging technologies, artificial intelligence, quantum computing, neural networks, consume more and more power as they expand. And we are only at the beginning of this trajectory. A Dyson swarm is not only the answer to physical survival, it is a response to intellectual growth. Now imagine an advanced civilization whose thoughts span centuries, whose minds communicate across planets, whose memories are stored in colossal archives orbiting their star. Their consciousness might extend into vast artificial substrates, machines woven into their swarm, processing ideas at scales unimaginable to us. They may build virtual worlds, neural networks of staggering depth, simulated realities where art, science, and philosophy unfold continuously. Every one of these requires energy, not a trickle, not a reservoir, a river. In this sense, the Dyson swarm becomes a kind of cerebral infrastructure, a power source for a species that has outgrown the neurological limitations of biology. The collectors feed not only habitats and terraformers, but data vaults, computation towers, and dream architectures. The swarm becomes the brainstem of a distributed civilization, pumping energy into the synapses of artificial and organic minds alike. And with energy abundance comes a new kind of peace. No more scarcity, no more competition over dwindling resources, no fear that thought itself might one day exceed the capacity of the world that hosts it. Instead, the civilization grows in harmony with its star, expanding its consciousness at the same gentle pace as its swarm. As you breathe softly now, imagine standing inside a quiet habitat filled with softly humming servers. The air is warm, lit by a faint glow. You can almost feel the flow of ideas, the collective dreaming of a species expanding its understanding of the cosmos. All of it powered by the steady pulse of starlight caught in delicate mirrors far above. In this moment of stillness, consciousness and energy intertwine. Thought becomes light transformed. Awareness becomes an echo of the star, and the Dyson swarm becomes not just a structure of survival, but a vessel for the unfolding mind of a civilization. If you trace the long arc of a civilization's story, from its earliest flickers of fire to its quiet mastery of technology, one truth appears again and again. As knowledge grows, so does light. Light in the literal sense, captured, stored, released. Light in the metaphorical sense, insight, wisdom, awareness. And light in the cosmic sense, energy, the currency of possibility. A Dyson swarm is the culmination of this arc, not because it represents power, but because it reflects a civilization's relationship with illumination, both physical and internal. Picture a world at the dawn of intelligence. The night is broken only by stars and small flames. Life survives in pockets of warmth. Then, slowly, tools appear. Homes glow, cities rise, electrical grids hum. Information moves at the speed of light through fibre and air. Each step forward brightens the world, not merely through lamps, but through the expanding horizons of thought. Curiosity itself has luminosity. It pushes outward, illuminating what was once unknown. But eventually a civilization outgrows its cradle. Its needs expand, not out of greed, but out of complexity. Its knowledge deepens, its culture diversifies, its dreams multiply. What was once sufficient becomes too small. The skies become research fields. The planets become laboratories. The solar system becomes a canvas. In this expansion, energy becomes the thread that binds everything together. More minds require more support. More exploration requires more fuel. More understanding requires more computation. And so the civilization seeks a steady, abundant source, a sun it has known since its beginning. A Dyson swarm in this sense is not a monument to power. It is a reflection of growth. It is the natural next step in a long lineage of gathering light, from fires to lamps, from lamps to grids, from grids to collectors orbiting a star. The civilization does not leap to cosmic scale overnight. It learns, it experiments. It develops a deeper sensitivity to its star's rhythms. Over time, its light becomes synchronized with the light of its sun, and something beautiful happens. The civilization's outward glow becomes an extension of the star itself. The artificial satellites shimmer like a second corona. Energy beams cross the system like luminous arteries. Habitats drift in orbit, glowing faintly with recycled daylight. Data flows. Agriculture thrives in places that were once dark. The entire solar system becomes a network of illumination, a tapestry woven from nature's radiance and intelligent design. In this growing light, fear recedes, scarcity fades, conflicts born from limited resources soften. The civilization begins to see time differently, not as a race against depletion, but as an invitation to continuity. The star offers more energy than the species could ever exhaust, and in return, the species offers gratitude, expressed not through worship but through stewardship. It builds responsibly. It maintains the balance between heat and harmony. It ensures that its great structures do not choke the star, but breathe with it. As you breathe gently now, imagine drifting near the edge of the swarm. Behind you stretches a field of collectors, each one glinting like a quiet star. Ahead lies the vastness of space, unlit except for the soft warmth of the system you just left. You realize in this moment that a civilization's light is not measured by brightness alone. It is measured by the intention behind it, by the wisdom with which it uses the energy it gathers. In this stillness, the growing light of a civilization becomes not a blaze, but a gentle glow, not a conquest, but a continuation. A flowering of possibility guided by the same radiance that once nurtured life on a single, fragile world. From the surface of a young world, a star appears unreachable, a distant fire suspended in the sky, warm enough to nurture life yet impossibly far away. For early civilizations, stars were myths, gods, mysteries. Then they became objects of study, measured and charted with steady curiosity. Only much later did they become destinations, but to imagine a Dyson swarm is to take yet another step, to see a star not merely as a distant lamp, but as a home, a place a civilization can inhabit, shape, and live alongside with quiet intimacy. Consider how strange, how transformative that shift truly is. Humans evolved under a single sun, but never approached it directly. We feel its warmth on our skin, but only through the filter of atmosphere. We study it from afar, protected by distance. We orbit it without ever touching its light at the source. Yet a species that builds mega-structures around its star rewrites this relationship. The star is no longer an unreachable furnace. It becomes part of the lived environment, as familiar as mountains and rivers. Imagine drifting in a habitat just a few million kilometers from your star. The sun, or whatever star your species calls home, fills a portion of the sky not with blinding intensity, but with softened brilliance filtered through the thousands of collectors that drift around it. Its light shifts gently across your living space, like the glow of a hearth reflected through stained glass. Your days are not measured by orbit, but by the steady rhythm of energy flowing through the swarm. To such a civilization, the star is a landscape. The corona becomes a horizon. Solar flares are weather. The shift in magnetic fields are seasons. The swarm floats within this environment the way trees nest in sunlight, adaptively, gracefully. It is an ecology of machines and habitats woven into the outer layers of a star's influence. In time, stories change. Children grow up not thinking of the star as a distant sphere, but as the luminous heart of their world, a place they visit through maintenance platforms, survey stations, and observation decks. They look down, not up, to study the luminous surface. Their concept of sky becomes layered. An inner glow, a field of drifting mirrors, a faint haze of infrared, and then the deeper dark of space beyond. Their myths, their poetry, their arts evolve around this intimate connection. The star becomes a companion in their cultural identity. Even more profoundly, their understanding of home expands. Home is no longer a planet. Home becomes the star system itself, a space defined by radiance, architecture, and shared purpose. Gravity wells matter less, surfaces matter less, warmth and power matter more. A civilization that lives among its collectors does not feel confined to a single world. It feels anchored to a star the way early species once felt anchored to fertile river valleys. As you breathe softly now, imagine this intimacy. Imagine standing on a transparent platform suspended above the shimmering swarm. Below you, the star unfurls in swirling gold and white. Above you, thousands of structures drift like a luminous reef. You are no longer an observer of the star, you are a resident of its light. In this stillness, the idea becomes clear and profound. A Dyson swarm transforms a star from a distant giver of warmth into a home, a place shaped with intention, inhabited with reverence, and woven gently into the fabric of living. When a civilization begins to reshape its star, building mirrors that drift in orbit, redirecting sunlight, mining worlds to forge collectors, it steps into a realm where physics and philosophy meet. The mechanics of constructing a Dyson swarm are complex, but the ethical questions are deeper still. Should a species rewrite its own sky? Should it reshape the cosmic environment that once shaped it? Engineering at such a scale is not merely technological, it is moral. It requires a civilization to confront the weight of its actions and the meaning of its legacy. Imagine living on a world where the sky slowly changes over centuries. At first, the swarm is small, tiny glints, barely noticeable. But as it grows, the star's light becomes softer, filtered, shaped by thousands of drifting surfaces. Sunrises take new colours, shadows lengthen differently. The night sky brightens faintly with the warmth released by the collectors. Generations are born under a sky their ancestors never knew. Some may find it beautiful. Others may grieve the loss of the familiar heavens. A species must navigate this emotional landscape carefully. Terraforming a planet raises ethical questions about ecosystems. Building a Dyson swarm raises ethical questions about identity. What does it mean to transform the very light that nurtured your evolution? What responsibilities come with wielding such power? Then there is the matter of the worlds that might be consumed. To mine a moon, strip an asteroid, or dismantle a dead planet is one thing. But what if a world holds ancient significance? What if it contains unique geological formations, relics of early life or cultural heritage? A civilization that builds among the stars must learn to weigh history against future, memory against necessity. And beyond the local system lies a wider moral horizon. A Dyson swarm is visible, subtly but undeniably, to observers in other parts of the galaxy. Its infrared glow becomes a signature, a declaration of technological maturity. Should a civilization choose to announce itself this way, or should it hide, wary of what unknown species might see the light? Silence and visibility each carry their own ethical implications. To glow is to communicate, intentionally or not. Even the star itself becomes part of the moral equation. Stars are not conscious, yet they are ancient, stable, and central to the harmony of a system. A species might ask, do we owe respect to the natural state of our star? The collectors do not harm it, but they change the way it shares its light. They alter its relationship with surrounding space. Is this simply evolution, a new expression of cosmic order, or a disruption of natural balance? As you breathe gently now, imagine a gathering of philosophers, scientists, and elders in a quiet hall suspended somewhere within the swarm. Outside the windows, mirrors drift gracefully, reflecting soft bands of starlight. In the silence between their words, the participants sense the magnitude of what they are shaping. They understand that their decisions ripple across generations, and yet they also understand that growth is not inherently destructive. A Dyson swarm need not be an act of domination. It can be an act of stewardship, managing the star's radiance to sustain life more safely and abundantly. Ethics becomes not a barrier, but a compass, a guide for choosing how to reshape the sky with wisdom rather than haste. In this serenity, the question remains open, spacious, and profound. To rewrite a sky is to rewrite the story of a civilization. And every civilization must decide what kind of story it wishes to tell. Every civilization, no matter how advanced, eventually encounters limits. Limits of energy, limits of resources, limits of biology, of imagination, of time. These boundaries do not always present themselves as barriers. Sometimes they emerge as gentle reminders, moments when a species realizes that its dreams have outgrown the world that nurtured them. The path towards a Dyson swarm begins, in many ways, with the quiet recognition of such limits. Consider a world that has thrived for thousands of years. Its forests flourish, its cities glow, its oceans sustain life. Knowledge expands, culture deepens, but slowly, subtly, the civilization's needs begin to press against the planet's finite bounds. Energy demands rise, populations grow. Data multiplies like a new form of life. The species begins to sense the edges of its cradle, the way roots sense the walls of a pot. Not out of fear, but out of awareness. The planet is enough, until it no longer is. At first, the instinct might be to push harder, to extract more, to innovate frantically within the old constraints. But wisdom often comes not from force, but from stillness. A civilization that pauses, that breathes, that listens to the subtle rhythms of its world may realize that the solution is not to strain at its boundaries, but to expand its perspective. The planet is not the limit. The star is not the limit. Even the galaxy, in time, may not be the limit. What limits exist are not walls, but horizons. The philosophy of limits invites a civilization to reflect. What does it truly need to thrive? What should it preserve? What should it release? How does it balance ambition with harmony? These questions shape the ethics of growth and the pace of progress. They guide decisions about energy, expansion, and the careful stewardship of natural worlds. A Dyson swarm in this light is not a rejection of limits, but an evolution of them. It acknowledges that a single planet cannot support the needs of a growing civilization forever. It accepts the reality that every world must eventually face ecological, cultural, or energetic constraints, and it embraces a new horizon, the star, as a place where growth can continue without exhausting the cradle that once sheltered life. Yet even the star imposes its limits. Its luminosity is finite, its lifespan defined by nuclear physics. A civilization building a Dyson swarm must confront these truths as well. The star will one day swell, cool, or collapse. The swarm will need to adapt, migrate, or transform. Limits shift, but they do not vanish. They simply move further into the distance, offering new opportunities for reflection. As you breathe gently now, imagine a philosopher standing on the balcony of a habitat orbiting within the swarm. Below them, the star glows in softened brilliance. Above them, collectors drift like luminous petals. They close their eyes and consider the paradox. Every limit overcome reveals a new horizon. Every horizon reached unveils a deeper question. Growth is infinite only in imagination. In reality, it unfolds step by step, shaped by careful choices and deep reflection. In this stillness, the philosophy of limits becomes not a restraint, but a guide, a gentle reminder that every species must learn to grow wisely, honouring both the boundaries it surpasses and the ones it chooses to keep. Every civilization faces a quiet tension woven into the fabric of its evolution, the pull between stillness and expansion. To stay rooted in a single world offers stability, familiarity, a sense of home. To reach outward, to other planets, other stars, other possibilities, offers growth, survival, and the unfolding of potential. A Dyson swarm embodies this paradox in its purest form. It is expansion on a cosmic scale, yet rooted in the deepest desire for continuity and peace. Imagine a civilization that has known its homeworld for millions of years. Its cultures bloom like forests, its languages flow like rivers, its stories echo across mountains and seas. There is richness in stillness, a kind of collective breath, a shared knowing that emerges only when generations grow under the same skies. Stillness nurtures identity. It anchors meaning, but over time, stillness alone becomes fragile. Storms, natural or self-made, may threaten the planet's stability. Populations grow, knowledge expands, horizons widen. A species begins to feel the edges of its cradle, sensing that remaining in one place forever is not safety, but vulnerability. The urge to expand does not come from greed. It comes from the understanding that survival, in the long arc of cosmic time, requires movement. Expansion, however, carries its own discomforts. To leave the homeworld is to let go of certainty. To build among the stars is to enter an environment vast and indifferent. A civilization must adopt a new rhythm, one shaped by orbital mechanics instead of seasons, by solar winds instead of breezes, by machine habitats instead of forests. Expansion demands courage. It demands openness to the unfamiliar. The soft paradox lies here. To endure, a civilization must expand. To remain itself, it must be still. A Dyson swarm, in this sense, becomes a middle path. It allows a species to stay close to its star, near the source of its original light, while growing outward in gentle, controlled layers. Habitats bloom in orbit while memories remain anchored to the world where life first appeared. The civilization becomes both rooted and unbound, local and cosmic, grounded and free. Picture a family living in a habitat within the swarm. Inside, their routines may feel much like life once did on their ancestral planet. Gardens grow. Water flows. Children play under curved ceilings that recreate skies with soft illumination. Yet outside the walls, countless other habitats drift. Energy streams through transmission lines. The star glows at the centre, and the homeworld remains a distant sphere below, cherished but no longer alone in carrying the weight of an entire species. Stillness becomes internal, held in culture, memory, relationships. Expansion becomes external, expressed in architecture, exploration, and the slow growth of the swarm. Neither is sacrificed. Both are woven together. As you breathe gently now, imagine the balance. A species sitting at the threshold between belonging and becoming. One hand resting on the soil of its origin, the other reaching towards starlight. The Dyson swarm is not a monument to ambition. It is a meditation on continuity. A way to grow without losing oneself. A way to move outward without drifting away. In this stillness, the paradox softens into harmony. Expansion becomes a kind of stillness stretched across space. Stillness becomes a form of expansion held within, and the civilization, quiet, thoughtful, luminous, learns to live in both truths at once. Whenever we imagine civilizations advanced enough to build Dyson swarms, we inevitably encounter a quiet, unsettling mystery. Where are they? The galaxy contains hundreds of billions of stars. Many of those stars are older than our Sun. Countless worlds could have formed long before Earth existed. If life arises naturally, if intelligence evolves with time, if curiosity is universal, then why do we not see the sky filled with signs of thriving luminous civilizations? This is the essence of the Great Filter. The idea that somewhere along the path from simple life to cosmic engineering lies a barrier, one so challenging, so unforgiving, that few species ever pass through it. It is not a literal wall, but a sequence of improbable steps, any one of which might halt a civilization's progress before it reaches the stars. Some philosophers believe the filter lies behind us, that life itself is rare, that intelligence is rarer still, that humanity has already crossed the most difficult thresholds and now stands in an open field of possibility. Others fear the opposite, that the filter lies ahead, that civilizations may flourish briefly, creating art, philosophy, technology, only to collapse under their own weight before reaching the maturity required for stellar engineering. This fear is not rooted in despair but in observation. History shows that species can be vulnerable to their own inventions, their own conflicts, their own imbalances. A world can warm too quickly. A weapon can grow too powerful. A society can fracture faster than it can unify. And yet, hope persists, because every generation also produces wisdom, compassion, and resilience. Civilizations learn. They adapt. They understand the value of stability, stewardship, and harmony. A Dyson swarm represents a species that has passed through many filters, not just technological, but emotional and ethical. It suggests a civilization that survived its fragile adolescence, resolved its destructive impulses, and found ways to sustain peace over centuries. No species still driven by short-term competition, conflict, or scarcity could coordinate a project so vast and so patient. It would require unity, cooperation, and a long-term vision shared across generations. Imagine, then, what such a civilization might feel like. A people who learned to manage their environment responsibly, who resolved their crises instead of amplifying them, who built systems that endure, protect, and uplift, who see their star not as a distant threat, but as a partner. The construction of a Dyson swarm becomes a symbol, a sign that the species did not fall to its own shadows, but grew beyond them. And yet the Great Filter remains a question, not an answer. Perhaps advanced civilizations are rare. Perhaps they're quiet by choice, hiding within the soft glow of their own infrared halos. Perhaps their megastructures blend into natural patterns, too subtle for our early instruments to detect. Or perhaps they are out there, far ahead of us, and we simply have not looked long enough. As you breathe softly now, imagine standing beneath a sky that holds both hope and uncertainty. The silence of the cosmos is not empty, it is contemplative. It invites us to reflect on our own future, on the challenges we have yet to overcome, and on the path we choose as a civilization. In this stillness, the great filter becomes not a warning, but a mirror, asking us who we wish to become, and whether we will grow gently enough, wisely enough, to one day reshape our own sky with the grace of those who passed through the darkness before us. Far beyond its engineering and physics, beyond its mirrors and sails and drifting collectors, the Dyson Sphere carries a meaning that touches something deep within the imagination of any civilization that contemplates it. It becomes a symbol, not of domination or ambition, but of hope. A hope that intelligence can endure, that cooperation can prevail, that life, fragile as it begins, can learn to hold its place in the vastness of the cosmos. In many ways, the Dyson Sphere is the opposite of despair. Despair says there is not enough energy, not enough time, not enough stability, not enough future. But a Dyson Sphere whispers a different truth, that the source of abundance has always been there, shining patiently above, that scarcity is not the final story, that the light which nurtured the first single-celled organisms could one day nurture entire worlds, entire cultures, entire epochs of existence. Imagine a civilization gazing at its star, understanding for the first time that the energy pouring into space every second could support trillions of beings, millions of habitats, centuries of dreams. The star becomes a promise, a guarantee that as long as its heart burns, life has a foundation on which to grow. The Dyson Sphere becomes the manifestation of that promise, a soft cradle of mirrors gathering the star's warmth with care. Hope also comes from the cooperation such a project demands. No single faction, no fleeting leadership, no moment of urgency can build a Dyson swarm. It requires trust over centuries, unity among billions, and a commitment to future generations. A civilization capable of such coordination would have resolved its internal fractures, learned to value stability over conflict, and chosen continuity over chaos. In this sense, the Dyson Sphere becomes a sign that the species has matured, not just technologically, but emotionally and socially. It also symbolizes resilience. Stars age, worlds change, cataclysms rise and fall. But a civilization that builds among the stars learns to weather these cosmic tides. It gains the freedom to adapt, to relocate, to reshape its habitats, and to thrive even as the universe evolves. The Dyson Sphere is not merely a structure, it's a safeguard against extinction, a quiet declaration that life refuses to fade. There is something deeply human, even universal, in the desire to build something that outlasts one's own lifetime. Cathedrals, monuments, libraries, traditions, they all reflect a longing for continuity. A Dyson Sphere is that longing intensified, stretched across an entire stellar system. It is a monument not of stone, but of light, not meant to be seen from afar, but to sustain those who live within its glow. As you breathe softly now, imagine a child growing up inside such a civilization. They look at the star not with fear of its distant immensity, but with affection. It is their companion, their source of warmth, their constant presence. They know their ancestors learned to live gently with it, to gather its energy without harming its nature, to build a future around its glow. That child learns, simply by existing, that cooperation can shape worlds, that hope can become architecture, that civilization can grow without losing its soul. In this stillness, the Dyson Sphere becomes more than a megastructure. It becomes a testament to what a species can become when it chooses patience over urgency, wisdom over dominance, and light over fear. If a species ever reaches the point where it can build a Dyson swarm, harvesting the light of its star, sustaining entire worlds through delicate networks of mirrored petals, then it must already be something extraordinary. not simply advanced in tools or machines, but advanced in temperament, in patience, in the way it understands itself and its place in the universe. To imagine such a civilization is to imagine the outcome of thousands or millions of years of growth, struggle, reflection, and wisdom. Picture a society that no longer fears scarcity, one that no longer fights over dwindling resources or shadows of wealth. Energy is abundant. Light is everywhere. Their homes glow gently with starlight woven through collectors. Their cities hum with quiet power. Their archives store millennia of memory without worry of running out of space. Such abundance changes the architecture of a mind. It softens fear. It transforms urgency into contemplation. It opens the door to curiosity unburdened by survival. In such a civilization, time moves differently. Projects span centuries. Art and science intertwine like vines. Philosophies grow deep roots. Children learn not only the mechanics of living in orbit, but the long story of how their ancestors crossed through the fragile phase of their species, how they navigated their great filter, how they learned cooperation, how they transformed conflict into continuity. History becomes a kind of shared meditation, not a list of mistakes but a guide toward harmony. Their technologies would reflect this calm maturity. Machines would be designed to repair themselves, to adapt, to learn. Entire fleets of autonomous builders would drift like metallic bees around asteroids and moons, constructing and maintaining the swarm without haste. Nothing would be rushed, nothing would be forced. Every improvement would be a refinement, every design a quiet evolution of the one before it. Such engineering feels less like invention and more like tending a cosmic garden. Their social structures too would adjust to this long arc. Governance might stretch across centuries of planning. Education would cultivate depth rather than urgency. Creativity would flourish in an environment where failure is simply part of an extended cycle, not a crisis. And because resources are not fought over, their civilization might be more peaceful, their culture more reflective, their values more aligned with longevity than with conquest. Imagine their art, sculptures that use solar illumination as moving colour, music composed across orbital resonances, literature contemplating the gentle motion of habitats drifting near the star. Imagine their rituals, gatherings timed to the rhythm of solar cycles, celebrations marking expansions of the swarm, moments of communal reflection when new collectors unfold in the dawn of the star. And imagine their perspective. They would see their star not as an obstacle, not as a god, but as a companion, a partner in existence. Their philosophy would likely include gratitude toward the light, reverence for continuity, and a deep understanding that survival is not a race but a relationship. They would live not in the shadow of cosmic threats, but in the warmth of knowing they have learned to thrive in concert with their star. As you breathe softly now, picture meeting such a civilization, not through language, but through the serenity of their presence. Their technologies hum quietly. Their habitats glow like floating lanterns. Their movements are patient. Their minds are expansive. In their calm, you sense something profound. They have learned to live with their universe rather than against it. In this stillness, the question arises not of how they built a Dyson swarm, but of who they became in order to build it. After drifting so far through imagined civilizations, luminous swarms, and the quiet choreography of mirrors orbiting distant suns, it is natural to turn our gaze back toward the place we began, our own star. The sun, familiar, constant, quietly generous, has watched the entire story of Earth unfold. Every heartbeat, every forest, every moment of human history has happened in its glow, and if you pause now, breathing softly, you can almost feel its presence even through the distance and darkness of night. We so often take the sun for granted, treating it as a simple backdrop to our lives. But in truth, It is the origin of almost everything. Each atom of warmth in your body was once the light of the sun, absorbed by leaves, breathed by oceans, carried through food and flame until it reached you. Each sunrise is a continuation of a story that began billions of years before there were eyes to see it. And every photon that touches your skin has travelled from the heart of the sun for thousands of centuries before arriving in that brief moment of warmth. In imagining Dyson spheres, massive swarms, interstellar civilizations, engineered skies, we are not turning away from our star. We are learning to see it again, with new appreciation. We are acknowledging its generosity. We are contemplating the possibility that one day our descendants might live closer to it, guided by its rhythms, sheltered by structures that reflect and honour its light. Imagine floating above the sun in a serene orbit, watching the corona shimmer like golden fire. Imagine seeing the solar wind streaming outward in ghostly ribbons. Imagine the quiet pulsing of magnetic loops rising and falling across its surface. Even in its violence, there is a profound beauty. Patterns shaped by physics, motion guided by laws older than planets. From that vantage, Earth appears small but unmistakably precious. A blue circle suspended in the dark, wrapped in clouds and memories, the home we come from, the origin of every story we tell. And yet, from the same vantage, the sun appears no longer distant or unreachable. It becomes something familiar, almost intimate. Its warmth feels close. Its light feels like the gentle breath of a companion. You realize in that moment that our star is not just a cosmic furnace. It is a presence woven into your very existence. And then another realization follows. If humanity ever builds structures around the sun, mirrors, sails, collectors, they will not be monuments of ambition, but offerings of gratitude. Ways to deepen our relationship with the star that has sustained us for so long. Ways to grow into the future without leaving behind the light that shaped us. As you breathe gently now, imagine that future. Not in detail, but in feeling. A civilization living in harmony with its star. A species that learned continuity instead of conflict. A people who see the sun not as something to escape, but as something to understand, to honour, to grow alongside. In this stillness, returning to our own star becomes a meditation, a reminder that even as we dream of distant worlds and cosmic megastructures, the warmth we seek has always been close, has always been constant, has always been home. As our journey nears its quiet end, the question that began this voyage drifts gently back into view. Could we ever build a Dyson Sphere? Or more softly, would we ever choose to? After wandering through the physics, the philosophy, the dreams of future civilizations, it becomes clear that the answer is not a simple yes or no. It is a horizon, broad, shimmering, shaped by time. Humanity stands at the earliest edge of that horizon. We are still learning to read the language of stars, still discovering how fragile our world can be, still navigating the delicate balance between innovation and harmony. And yet, the very act of wondering about Dyson spheres reveals something profound, that we already feel the pull of the future, the invitation of possibility. A Dyson sphere is not merely a structure, it is a symbol of long-term thinking. To build one requires centuries of stability, cooperation, and trust. It requires a civilization that has moved beyond the storms of its early history, beyond scarcity, beyond conflict, beyond short-sightedness. In imagining such a structure, we imagine a future version of ourselves that has learned patience, resilience, and unity. Whether or not we ever construct a swarm of mirrors around the sun, the vision itself acts as a compass, pointing us toward a gentler, wiser way of living. And consider this, humanity already reshapes its relationship with light. We build solar farms across deserts. We install panels on rooftops. We launch satellites that sip sunlight above the atmosphere. These are small steps, but they echo the first seeds of the mega-structural dreams we've explored. A Dyson swarm is simply those steps extended across eons. It is not an alien thought, just the natural continuation of our journey toward illumination. Still, the question lingers like a soft breeze. Should we build one? Perhaps the answer depends on who we become. A civilization that rushes may not be ready. A civilization that fears may not endure. But a civilization that grows slowly, thoughtfully, with reverence for its star and its homeworld, that civilization may one day find that the Dyson swarm is not an act of ambition, but an act of belonging, a way to settle deeper into its place in the cosmos. As you breathe gently now, imagine humanity far in the future, not grand or triumphant, but peaceful. City powered by endless sunlight, habitats orbiting in calm arcs, knowledge shared freely, conflicts softened by abundance, the sun shining at the heart of this world, its light woven into the fabric of every life. Whether or not a Dyson swarm fully encircles it, the essence remains the same, a species that learned to grow without losing its centre. And perhaps that is the real answer. The meaning of the Dyson Sphere is not about engineering, it is about relationship. About how a civilization chooses to live with its star, about whether it approaches the future with fear or with trust, about whether it sees the cosmos as a battlefield or as a home. In this stillness, as our thoughts settle like dust drifting through light, the question becomes soft and spacious. Not, will we build one? But who will we be when the time comes? And now, as our long journey drifts toward quiet, let your breath slow. Let the ideas settle like soft dust illuminated by the dim glow of a distant sun. We have wandered far, across imagined futures, across cosmic structures, across the delicate choreography of mirrors and sails that might one day cradle the light of an entire star. But all these vast visions return us gently to a single truth. Every great dream begins with stillness, with a thought, with a moment of curiosity held tenderly in the mind. The Dyson Sphere, for all its grandeur, is at its heart a meditation on connection, a civilization reaching out not to conquer its star, but to live with it more deeply, to understand its warmth, to honour its generosity, to shape a future not bound by fear of scarcity or collapse, but guided by the quiet confidence that light, steady, ancient, abundant, can sustain life for ages beyond counting. It whispers that survival is not always a struggle. Sometimes survival is an act of harmony. As you rest here, imagine the star at the centre of your own life, not as a distant point of heat, but as a companion whose light touches every breath you've ever taken. Imagine drifting in a serene orbit, the sun filling your sky, softened by the gentle shimmer of collectors floating like petals. Imagine the warmth around you not as harsh fire, but as a cradle, an environment shaped with wisdom and care. Perhaps this civilization of the far future is not alien at all. Perhaps it is simply an evolved version of us. Humanity grown patient, attentive, attuned to the rhythms of the cosmos. A species that has learned to listen, learned to build without harm, learned to expand without losing its centre, learned above all to continue. And now imagine yourself drifting farther, gently pulling away from the star, watching the luminous halo shrink into the distance. The collectors become points of light, the star becomes a soft ember, the vastness opens around you, quiet and calm. Yet within that calm there is comfort, the knowledge that life can endure, that intelligence can grow, that hope can take the form of mirrors orbiting a sun. Let your thoughts drift like those mirrors. Let your breath slow to match the rhythm of orbits. Let the quiet of the cosmos settle over you like a warm blanket. You are safe here. You are floating through wonder. You are part of a universe that, even in its silence, offers beauty without end. And now, as night deepens around you, Allow yourself to release every remaining weight. Let them fade into the starlight. Let them dissolve into the dark where the mind stretches out like a horizon and the heart finds its resting place. Everything flows. Sleep in that motion.